The mind is an extraordinary landscape, a living archive of every whisper of experience that has ever passed through the senses. Within it lies the story of one's life, moments cherished and moments forgotten, thoughts half remembered, the scent of morning air after rain, the familiar voice of someone long absent. All these fragments weave together into the seamless illusion of continuity we call self. Memory, in essence, is not merely a record of what has happened. It is the foundation upon which consciousness itself quietly stands. Without memory, the mind would awaken each morning into a world forever new and unfamiliar, stripped of meaning and recognition. As you lie still and let your body rest, imagine the gentle hum of the brain at work. Even now, in the dark calm of night, it continues its delicate choreography of remembrance, sorting, storing, and connecting impressions gathered through the day. Every sensation that touches the body leaves a faint trace within this vast neural network. Most fade quickly, like ripples upon water. Others take root, shaped and reinforced through repetition and emotion, growing into lasting recollections that accompany us for years or even a lifetime. The process is as natural as breathing, yet more intricate than any system ever designed by human hands. When scientists speak of memory, they often divide it into three broad categories: short-term memory, working memory, and long-term memory. Each serves a unique purpose, and together they form a continuum through which information flows. Short-term memory holds information for only a few moments, perhaps the sound of a name, the number of a room, or the words of a sentence you are reading right now. Working memory, on the other hand, is the mind's mental workspace. It not only keeps information temporarily active, but also manipulates it, reordering thoughts, comparing patterns, solving problems, and beyond both lies the vast expanse of long-term memory, a library of experience that stores knowledge, skills, language, and identity itself. But before any of these forms of memory come into play, information must first enter the mind through the senses. In this initial stage, sensory memory acts as the briefest of gatekeepers. It captures raw sensory impressions, the shimmer of light, the tone of a voice, the scent of pine in the air for mere fractions of a second. Iconic memory holds visual images for less than half a second. Echoic memory preserves sound for 2 or 3 seconds longer. Without this fleeting storage, the world would seem fragmented, each moment cut off from the next. Sensory memory smooths perception into continuity, allowing the mind to comprehend a sentence, recognize a melody, or follow the motion of a falling leaf. From there, attention determines what survives. Out of the endless flood of sensory detail, only a handful of elements are selected for deeper processing. Attention acts like a beam of light, illuminating certain pieces of information while the rest fade into obscurity. What you notice is what you remember, at least in the beginning. The sound of your name in a crowded room, a sudden change in temperature, or a flash of color that catches your eye. These draw the mind's focus, granting them a brief audience within short-term memory. Short-term memory is often likened to a stage upon which the mind's immediate thoughts perform. Its capacity is famously limited, perhaps 7 items, give or take a few, and its duration no more than 20 or 30 seconds without rehearsal. Yet, within that narrow span, it performs miracles of organization. It allows you to remember the beginning of a sentence until you reach its end, to dial a phone number after hearing it once, or to recall the last few notes of a song you are humming. When information is rehearsed, repeated silently or aloud, it can remain active longer and stand a greater chance of being passed along to long-term storage. Working memory expands upon this idea. It is not merely a passive storehouse, but a dynamic system that manipulates and reorganizes information in real time. Imagine trying to calculate a sum in your head, or following the steps of a recipe while cooking. The brain holds multiple pieces of information simultaneously: numbers, instructions, sensory feedback, and continuously updates them. The prefrontal cortex, located just behind the forehead, plays a central role in this delicate balancing act. It coordinates attention, planning, and problem solving, while other brain regions contribute specialized forms of processing. Working memory thus represents the meeting point between perception and action, the space where thought takes form. But memory is not contained in a single location. It is a process woven throughout the brain's architecture. The hippocampus, a curved structure deep within the temporal lobes, serves as a crucial intermediary. It acts as a bridge between short-term experience and long-term storage, encoding new events and linking them with existing networks of knowledge. When you encounter something novel, a new face, a place you have never been, the hippocampus records its essential details and gradually transfers them to the cerebral cortex for permanent storage. Without it, new memories would never solidify. Individuals who suffer damage to this region often retain their past but are unable to form new memories, living perpetually in the present moment. The cortex itself, the brain's outermost layer, holds the great mosaic of long-term memory. Unlike a library with neat shelves and labeled volumes, the cortex stores memories in a distributed fashion. Visual aspects of a memory may reside in the occipital lobes at the back of the head. Sounds and words are processed in the temporal lobes near the ears. Tactile and spatial details are mapped within the parietal regions. And emotional color is provided by the limbic system. When you recall a past experience, these fragments reassemble through synchronized neural activity, producing a seamless recollection that feels like stepping back into the moment itself. In this way, memory is not a static record, but an active reconstruction. Each act of remembering slightly reshapes the memory, strengthening certain pathways while letting others fade. Over time, this gentle rewriting integrates new experiences with old, allowing the mind to adapt without losing its sense of continuity. It is as though the story of self is constantly being revised, edited, not for accuracy, but for coherence, ensuring that the narrative of one's life remains whole and comprehensible. As you breathe slowly, consider how many layers of memory operate within you at this very moment. The words you are hearing are held briefly in working memory as your brain constructs meaning from them. The knowledge of language itself resides in long-term networks built over years of exposure and learning. Beneath all that, the subtle rhythm of your breath and heartbeat are maintained by implicit memory, guiding actions you do not consciously recall learning. Every gesture, every thought, every recognition is a small act of remembering. The beauty of memory lies in its balance between fragility and endurance. It can vanish in an instant, lost to distraction, time, or sleep, and yet some memories remain vivid for decades. Neuroscientists believe that sleep itself, particularly deep and dream-rich phases, plays a critical role in solidifying what we have learned. During slumber, the hippocampus replays patterns of neural activity experienced during the day, gently reinforcing connections within the cortex. It is as though the mind, freed from the noise of waking life, revisits its memories to decide which to keep and which to release. Through this process of nightly renewal, the brain maintains its delicate equilibrium. Not every memory is meant to last. Forgetting, though often lamented, is as essential as remembering. It clears space, reduces noise, and allows for focus on what truly matters. The human memory system, then, is not a simple storage device, but a living, breathing process of selection, transformation, and meaning-making. And so, as the body relaxes and the mind drifts toward rest, one can imagine the quiet workings of this intricate system. Neurons exchanging faint sparks of communication, circuits whispering softly to one another, the hippocampus weaving patterns that link today's experiences with the timeless tapestry of what has come before. In that serene darkness, the boundaries between learning and dreaming blur, and the human mind, ever curious, ever awake, continues its eternal dialogue with memory itself. 2. The journey of a thought. Every thought begins as something almost invisible, a small pulse of energy rippling through the vast electrical ocean of the brain. Before it becomes a memory, before it takes shape as understanding, it exists only as a pattern of activity, a fleeting constellation of neurons communicating in silence. This is where the journey of a thought begins, deep within the invisible architecture of perception and attention. Imagine for a moment that you are standing outside on a calm evening. A soft breeze passes across your face, carrying the faint scent of rain on the air. The sound of distant leaves shifting in the wind reaches your ears, and your eyes register the subtle dimming of light as the sun slips lower in the sky. These sensations, smell, sound, sight, touch, enter the nervous system in a continuous stream of electrical impulses. Millions of sensory receptors scattered throughout your body and the surface of your eyes, ears, and skin act as translators. This translation marks the very first step in the creation of memory. Sensory encoding. Each sense has its own network of pathways leading to specific regions of the brain. Light is captured by photoreceptors in the retina and sent to the visual cortex at the back of the head. Vibrations in the air stimulate the tiny hair cells of the inner ear, which translate those movements into electrical messages for the auditory cortex. Every smell, taste, and texture follows its own route, all converging in the brain's sensory areas where raw information becomes the building blocks of experience. But even at this early stage, perception is selective. The brain does not register every detail. It does not need to. Instead, it filters and prioritizes, discarding much of what the senses provide. Attention acts as a quiet gatekeeper, allowing only certain signals to move further into awareness. It is drawn by novelty, by change, and by meaning qualities that suggest something important to survival or understanding. Thus, in the gentle hum of evening sounds, one might notice the sudden trill of a bird or the faint tapping of rain because these stand apart from the background. This act of noticing is the spark that begins the process of memory formation. Once attention is directed toward a particular stimulus, that information is held briefly in sensory memory, a momentary trace that lasts only a few seconds. During this fleeting window, the brain decides whether to discard the information or send it forward for further processing. If the experience captures your focus, perhaps the sound of your name being called or the glimmer of lightning at the horizon, it passes into short-term memory, the first conscious stage of thought. Here it remains, active and vivid, for a few seconds longer. At this point, the brain begins to weave the raw sensations into meaning. The auditory cortex recognizes the sound of the word that was spoken, while the language centers in the temporal and frontal lobes interpret its significance. The visual cortex interprets the pattern of light and shadow as the movement of clouds or the silhouette of a familiar tree. These interpretations are not isolated. They converge through networks of association. The hippocampus, always listening, begins to connect these new inputs to stored knowledge, linking the sound of the word to the memory of a voice, the sight of the clouds to previous evenings you have known. In this subtle way, perception and memory meet, and a simple moment becomes part of a larger pattern of understanding. Working memory now comes into play. It is the mental workspace that allows you to hold multiple pieces of information at once while combining them into a coherent whole. Suppose you hear someone ask you a question about the weather. To respond, your working memory must juggle the sound of the question, your observation of the sky, and your recollection of recent rain. The prefrontal cortex orchestrates this coordination, keeping relevant details active while filtering out distraction. Within seconds, the brain constructs a response, a small act of reasoning that feels effortless, yet relies on the collaboration of many regions working in harmony. Meanwhile, every new thought sends ripples through existing neural networks. When two or more neurons fire together, their connection strengthens slightly, a phenomenon known as synaptic plasticity. Over time, Repeated activity reinforces these pathways, making future communication easier. This principle, summarized simply as cells that fire together, wire together, underlies all learning and memory formation. Each repetition of an idea, each revisiting of an experience, carves the pathway a little deeper, transforming a fragile trace into something more enduring. The hippocampus, nestled within the temporal lobe, plays a central role in this process, acting as a kind of neural librarian. It takes the temporary patterns of working memory and encodes them for long-term storage. It identifies relationships between pieces of information. When you later recall the scene of that evening, the scent of rain, the sound of the wind, it is the hippocampus that reactivates the network, allowing the memory to rise gently back into consciousness. Yet not all thoughts complete this journey. Most impressions fade before they reach long-term storage, lost to the quiet tide of forgetting. The brain saves energy by keeping only what it deems useful or meaningful. Emotional relevance, repetition, and novelty all increase the likelihood that a thought will endure. An ordinary moment may vanish within minutes, while a moment that stirs emotion or demands focus can persist for decades. This selectivity is not a flaw but a form of efficiency, allowing the mind to maintain balance between retention and renewal. Deep within the brain's structure, another form of encoding takes place. If a thought carries strong feeling joy, fear, love, or surprise, the amygdala marks it as important, amplifying the encoding process. This is why emotionally charged memories often remain vivid, their details preserved with almost photographic clarity. The emotional imprint serves as a signal, instructing the hippocampus and cortex to prioritize these memories during later consolidation. As the brain encodes and organizes these signals, it also begins to integrate them with prior knowledge stored throughout the cortex. New information rarely stands alone. It finds its place among existing frameworks, expanding or reshaping them. When you learn a new word, for example, your brain links it to related concepts already stored in memory. When you meet someone new, your impressions connect unconsciously to patterns of familiarity, faces, gestures, tones of voice that you have encountered before. This process of association not only helps with recall but also gives meaning to experience, transforming isolated perceptions into understanding. While all of this occurs in the span of a few seconds, the brain continues to refine the thought long after it first appears. As you drift into rest, the hippocampus replays the patterns of neural activity involved, quietly rehearsing them in coordination with the cortex. This nocturnal repetition strengthens the pathways, transferring details from temporary to more durable circuits. In the morning, the thought that began as a momentary perception may have taken root as memory. The journey of a thought, then, is both brief and eternal. It begins in the flicker of a neuron and ends in the story of a life. It can last for the span of a heartbeat or remain for a lifetime, guiding choices and shaping identity. Every memory you carry, every fragment of knowledge or whisper of emotion was once a fleeting electrical pattern just like this. What gives it endurance is the quiet persistence of the brain's connections, the repeated dance of neurons that have learned to recognize one another's rhythms. Even now, as you lie still and listen, your brain is carrying out this delicate process. The words you hear enter through your ears, travel along auditory pathways, and are interpreted by language centers in your temporal and frontal lobes. Each phrase you understand becomes a small pattern of activity, momentarily alive in working memory. If these patterns resonate, if they link to something meaningful or familiar, they may find their way into the hippocampus, where they will rest until sleep has a chance to weave them more deeply into the fabric of your long-term memory. The entire process unfolds seamlessly, without conscious effort. You do not choose to remember. Your brain decides quietly, guided by emotion, relevance, and repetition. It is a system honed by millions of years of evolution, designed not only to preserve the past, but also to prepare for the future. Every remembered thought contributes to prediction, allowing the mind to anticipate outcomes, recognize patterns, and navigate the world with grace. In the stillness of this moment, as your breathing slows and the mind begins to drift, that same process continues. Thoughts fade gently, leaving behind faint imprints that may bloom into memories by morning. The brain, ever patient, tends to its garden of recollection, nurturing the seeds that will one day grow into understanding. In this quiet rhythm between remembering and forgetting, the human mind finds its balance, forever perceiving, encoding, and dreaming its way through the endless journey of thought. 3. Short-term memory, the mind's holding space. Within the calm rhythm of thought, there exists a fragile space where information pauses for only a brief moment before either fading away or settling deeper into the mind. This space is known as short-term memory, and though its capacity is limited, it is essential for almost every act of awareness and understanding. It is here that the mind first gathers the pieces of experience, arranging them into a form that consciousness can hold. Without this fleeting storage, sentences would dissolve before they could be understood, and the simplest actions, dialing a number, recalling a direction, or finishing a thought, would become impossible. To imagine short-term memory, picture a small pool in the current of a stream. Water flows in constantly, and some of it swirls briefly in place before moving on. The pool never holds the same water for long, but without it, the stream would rush past too quickly for reflection. Short-term memory performs a similar function within the continuous flow of sensory input. It provides a momentary pause, a breath of mental stillness, allowing perception to be examined before it disappears. Information reaches short-term memory through attention. Out of the countless impressions flooding the senses, attention selects only a few, giving them enough focus to be temporarily maintained. This selective process is vital because the human brain cannot process every detail of the surrounding world. At any given second, millions of signals compete for recognition: colors, sounds, sensations, and thoughts, yet only a handful reach conscious awareness. Those that do are held within short-term memory, sustained by the quiet repetition of neural activity across specific circuits. The duration of short-term memory is remarkably brief. Without active rehearsal, most information fades within 20 or 30 seconds. A phone number heard once, a phrase just read, or a new name introduced in passing, all will likely vanish unless they are repeated or associated with something meaningful. The psychologist George Miller, in his classic research, described this limit as the magical number 7, plus or minus 2, referring to the number of discrete items that can be stored at once. Though modern research suggests that this capacity varies and may often be smaller, the principle remains the same. Short-term memory is narrow, selective, and quickly fleeting. Yet despite these limits, the system is far from simple. The brain does not merely store raw bits of information. It organizes them into units known as chunks. Chunking allows multiple elements to be grouped together as a single unit based on meaning or familiarity. For instance, remembering the sequence 1492 as 1492 ties it to the familiar date of Columbus's voyage, instantly reducing 4 separate numbers to one meaningful chunk. In everyday life, this process operates effortlessly. Words group into phrases, faces into people, and sounds into recognizable patterns. In this way, short-term memory bridges perception and understanding, transforming the scattered fragments of experience into cohesive wholes. Neuroscientifically, the maintenance of short-term memory relies on the sustained firing of neurons across networks in the frontal and parietal lobes. The prefrontal cortex, in particular, acts as a kind of conductor, directing attention and holding relevant information active for as long as it is needed. When you are trying to remember a short list of groceries or repeating directions to yourself, this region remains engaged, sending rhythmic bursts of electrical activity that keep the memory trace alive. The moment your attention drifts, however, the activity ceases, and the memory begins to fade like chalk washed from a slate. Short-term memory is closely intertwined with the concept of working memory, the dynamic manipulation of information held temporarily in mind. While working memory involves using and transforming data, short-term memory refers specifically to holding it. One might think of short-term memory as the shelf, and working memory as the hands that move items upon it. The two processes operate together constantly, forming the foundation of conscious thought. Consider the simple act of reading this sentence. As your eyes move across the page, the words you've just seen linger briefly in short-term memory, while new ones enter through your senses. The overlap between what you've already read and what you are currently seeing allows meaning to emerge as a continuous flow rather than a series of disjointed fragments. Without short-term memory, comprehension would collapse into chaos, for each word would vanish the instant it was perceived. This transience is part of what makes short-term memory so delicate and yet so essential. It is not meant for permanent storage, but for the immediate handling of experience. Its purpose is to serve as a transitional space, passing selected information onward to the hippocampus for encoding into long-term memory when conditions permit. Repetition, association, and emotional significance can strengthen this transfer, increasing the likelihood that a fleeting thought becomes a lasting recollection. Rehearsal plays a crucial role in extending the lifespan of short-term memory. When you repeat a phone number to yourself, perhaps whispering it under your breath, you are engaging in what psychologists call maintenance rehearsal. Each repetition briefly refreshes the neural pattern associated with that information, delaying its natural decay. A more powerful form of rehearsal, known as elaborative rehearsal, goes a step further by linking the new information with prior knowledge. For instance, if you associate that phone number with a familiar birthday or pattern, the temporary nature of short-term memory is not a flaw but a feature. Its fleeting quality allows the mind to remain adaptable, responsive, and free from overload. Imagine if every small detail of every moment were preserved permanently. The texture of every fabric, the flicker of every shadow, the sound of every passing car. The mind would drown in the sheer weight of experience. Instead, short-term memory allows us to hold what is immediately necessary and release the rest, ensuring that the flow of consciousness remains light and clear. Even so, the process is not perfect. Distraction, fatigue, and emotional interference can easily disrupt short-term memory. When attention is divided, fewer resources remain to sustain the active patterns required for retention. This is why multitasking often leads to forgetfulness, why you may walk into a room and momentarily forget why you came, or misplace an object that you were holding just moments earlier. The memory was there briefly, but without sufficient focus, it slipped away before being consolidated. In daily life, the interplay between short-term and long-term memory is constant. Every conversation, every glance, every task relies on the seamless exchange between them. The hippocampus acts as the bridge, deciding which experiences should cross into the more permanent realms of storage. When repetition or emotional relevance signals importance, the hippocampus encodes the memory, strengthening synaptic connections that will allow it to be reactivated in the future. When no such signal occurs, the trace fades, its energy absorbed back into the quiet rhythm of the brain. Scientists studying short-term memory often describe it as a form of active neural reverberation. The same small cluster of neurons repeatedly activates one another in a loop, maintaining the information as long as attention persists. When the loop is broken through distraction or interference, the pattern collapses. This fragile stability mirrors the delicate balance of thought itself, sustained by focus, extinguished by neglect. In meditation, for instance, practitioners learn to observe this process directly, watching thoughts arise, linger briefly, and dissolve, leaving behind only the awareness that witnessed them. Short-term memory is also shaped by context. Information that fits meaningfully within the current situation is easier to maintain. For example, if you are told a list of fruits, apple, banana, pear, orange, you will likely remember more items than if the list mixes unrelated words. The mind naturally organizes data into patterns, and these patterns strengthen temporary storage. Contextual association acts as a silent aid, binding details together so that recalling one often revives the others. It is in this ephemeral domain that the present moment truly resides. Each second of awareness depends on short-term memory to maintain continuity, stitching together what has just passed with what is unfolding now. Without it, the flow of consciousness would fragment into isolated flashes. This quiet function, so easily overlooked, forms the bridge between perception and understanding, between experience and meaning. As night deepens and the body settles into stillness, short-term memories from the day's events flicker softly within the hippocampus, some fading as they lose significance, others replayed and strengthened through subtle bursts of neural activity. The brain, ever patient, reviews the moments worth keeping, allowing the rest to dissolve into the background of sleep. Short-term memory, then, is not simply a container for thoughts. It is the heartbeat of awareness itself, the rhythm that holds experience long enough for comprehension to bloom. It carries the raw material of the present, sustaining it just long enough for the deeper machinery of memory to weave it into the enduring tapestry of the self. And when it finally releases its hold, it does so with quiet grace, allowing the mind to remain open and ready for the next moment that will arrive, shimmering and new, waiting once more to be held in the delicate, fleeting embrace of thought. 4. Working memory, the brain at work. Working memory is the silent craftsman of the mind, the mental space where thoughts are not only held but actively shaped and reformed. It is the bridge between perception and action, a place where information is temporarily stored, compared, and manipulated in service of understanding and decision. Unlike short-term memory, which simply holds information for a brief interval, working memory is dynamic. It takes those pieces and rearranges them, turning raw sensory input into meaningful patterns. It is what allows us to reason, to solve problems, and to create connections between ideas that have never before touched. Imagine standing in your kitchen, following a recipe. You read the line, add 2 cups of flour, 1 cup of sugar, and half a cup of butter. In that moment, your eyes move from the page to the ingredients. Your hands reach for the correct measures, and your mind holds each quantity just long enough to complete the step. This coordination, this seamless interplay of reading, remembering, and acting depends entirely on working memory. It is the conductor of mental activity, balancing what has just been perceived with what must be done next. At its core, working memory can be thought of as a temporary workspace, a mental desk upon which ideas are laid out and rearranged. The prefrontal cortex, located at the front of the brain just behind the forehead, serves as the central hub for this activity. Here, neurons maintain patterns of activation that represent the items being held in mind, refreshing them continuously through loops of electrical communication. These loops allow the brain to keep information available for manipulation, performing arithmetic in your head, interpreting the structure of a sentence, or remembering the next step in a sequence of actions. But working memory does not act alone. It collaborates with several other regions throughout the brain, forming a network that coordinates perception, language, and emotion. The parietal lobes provide spatial awareness, helping us to visualize relationships between objects or numbers. The temporal lobes contribute auditory and verbal information, essential for inner speech and language comprehension. The hippocampus, though better known for long-term storage, provides contextual links that give working memory its depth and meaning. In essence, working memory functions as a conductor leading a vast orchestra of neural systems, each playing its part in the symphony of thought. The capacity of working memory is limited, but its flexibility is extraordinary. On average, a person can hold between 4 and 7 distinct pieces of information at once, yet through organization and association, this can be expanded. Consider trying to remember a long sequence of numbers. If you break them into familiar patterns, perhaps dates or phone number groupings, you increase what the mind can manage. This technique, known as chunking, transforms fragments into meaningful wholes. It is one of the many ways working memory adapts to its natural limits. Within this workspace, information is not static, but constantly shifting. It is updated, reevaluated, and occasionally discarded as new input arrives. This continual adjustment allows us to remain oriented in the present moment, responding fluidly to changes in environment and context. Without working memory, the mind would be trapped in an endless loop of the immediate, unable to compare the current moment to what came before. A simple conversation, for example, would be impossible. Each sentence would dissolve before it could relate to the next. Working memory provides continuity, allowing language, logic, and learning to unfold across time. In daily life, the subtle influence of working memory touches nearly everything. When you read a paragraph, the first line must remain active in your mind to understand the last. When you plan a route across town, you must visualize landmarks, anticipate turns, and adjust directions, all while monitoring the flow of traffic. When you hold a thought mid-conversation, waiting for the right moment to speak, every decision, every moment of problem-solving or comprehension draws upon this same mechanism. Scientists have come to describe working memory in terms of its components: the central executive, the phonological loop, and the visuospatial sketchpad. While these terms serve as useful metaphors, what they truly describe is the brain's remarkable ability to manage multiple kinds of information simultaneously. The central executive acts as a manager, directing attention and allocating resources where needed. The phonological loop holds and rehearses verbal or auditory information, the words of a sentence. The visuospatial sketchpad maintains mental images and spatial relationships, allowing one to picture shapes, paths, or scenes. Together, they provide the structure through which the mind holds both sound and sight in balance. The functioning of working memory is energetically costly. It requires continuous neural firing, a steady hum of electrical activity across interconnected regions. The prefrontal cortex must maintain delicate patterns of synchronization, and as those patterns begin to fade through fatigue, distraction, or overload, our ability to focus diminishes. When you lose track of a conversation halfway through or forget what you meant to say, it is not because the memory has vanished entirely, but because the pattern that held it has decayed. The system resets itself, ready for new input, but in doing so, releases the thought that was held only a moment before. This transience underscores the importance of attention. Working memory depends on attention to select and sustain relevant information. If attention wavers, the contents of working memory begin to crumble, replaced by whatever captures the senses next. In modern life, where countless stimuli compete for awareness, this vulnerability becomes clear. A sudden notification, a passing sound, even a stray thought can sweep away what was once firmly in mind. To strengthen working memory, therefore, is to cultivate steadiness of focus, to train the mind to linger gently upon one thing at a time. Despite its limits, the adaptability of working memory allows it to extend beyond the present moment through practice and training. Repetition strengthens the neural pathways involved, increasing efficiency and stability. Musicians, chess players, mathematicians, and language learners all rely on this kind of mental refinement. Over time, what once required deliberate effort becomes automatic, transferring from the temporary circuits of working memory into the enduring networks of long-term memory. Skill acquisition itself is, in essence, the gradual migration of patterns from conscious manipulation to unconscious fluency. Emotion also plays an intimate role in the workings of this system. The amygdala and other limbic structures communicate continuously with the prefrontal cortex, influencing what information is prioritized. Emotionally charged material tends to hold attention longer, making it more likely to remain active within working memory. This connection between feeling and thought enhances decision-making but can also lead to bias. A memory tinged with anxiety or excitement may dominate the mental workspace, narrowing focus and shaping perception. In quiet moments of reflection, however, this same link can deepen insight as emotion colors thought with meaning and resonance. Working memory is fragile, but it is also resilient. It resets and renews itself constantly, adapting to the ever-changing demands of life. It functions not through the accumulation of data, but through the continuous flow of energy and pattern. Each act of attention, each moment of reasoning, is a small act of construction, an assembling of elements that did not previously coexist. This creativity is what allows human thought to extend beyond instinct, to imagine possibilities and envision futures that do not yet exist. As the night deepens and the body grows still, working memory begins to quiet. The steady hum of activity in the prefrontal cortex slows, and its delicate networks release the thoughts they have been holding. What remains is passed to the hippocampus, where it may be consolidated into long-term memory during sleep. The rest simply fades into the soft background of consciousness, leaving the mind lighter and ready for renewal. In this nightly rhythm, we see the true nature of working memory, revealed not as a storehouse, but as a living process. It is the mind in motion, the place where awareness takes form and then dissolves. Each thought it shapes is temporary, yet through their succession, an enduring self emerges. The plans you make, the words you speak, the understanding you gain, all arise within this luminous workspace of the brain. It is here, in the quiet circuitry of attention and intention, that thought becomes action and perception becomes meaning. Even now, as your breathing slows and your body rests, your working memory hums softly in the background, weaving the words you hear into understanding. Soon, it will surrender them to deeper layers of the mind. The mind, ever graceful in its balance between activity and stillness, continues its eternal work constructing, reflecting, and gently releasing, thought by thought, into the quiet flow of consciousness. 5. The role of the hippocampus, deep within the folds of the human brain, nestled in the temporal lobes on either side of the head, lies a small, curved structure that resembles the shape of a seahorse. Its name, hippocampus, comes from the Greek words for horse and sea monster, and though its appearance may seem unassuming, its role in the architecture of memory is nothing short of extraordinary. The hippocampus is the mind's quiet archivist, carefully taking the fleeting impressions of the present moment and transforming them into the enduring patterns that make up long-term memory. Without it, life would be stripped of continuity. Each day would unfold as if in isolation, untethered from what came before. The hippocampus is part of a broader system known as the limbic network, a constellation of structures deep within the brain that govern emotion, motivation, and memory. While other regions contribute to memory storage and retrieval, the hippocampus serves as the gateway through which experience must pass to become permanent. It is here that the raw materials of perception, sights, sounds, words, feelings, are combined into coherent records of lived experience. Scientists often describe its role as one of consolidation, the process by which fragile, short-term traces are gradually stabilized and integrated into the more durable circuits of the cerebral cortex. Imagine your brain as a vast library. The cortex represents the endless shelves where knowledge, skills, and experiences are stored. The hippocampus, in contrast, is the librarian who receives new books each day, catalogs them. It cannot store everything indefinitely, but it ensures that important experiences are properly recorded and cross-referenced, ready to be found again when needed. For this reason, damage to the hippocampus results not in the loss of old memories, but in the inability to create new ones, a condition known as anterograde amnesia. Individuals with this condition can recall events from years past with clarity, but cannot remember what they ate for breakfast or who they met that morning. The hippocampus functions in constant communication with the rest of the brain. When a new event occurs, perhaps you walk into a new room, the visual cortex records shapes and colors, the auditory cortex interprets sound, and the somatosensory areas register touch and temperature. These scattered impressions converge within the hippocampus, which binds them together into a unified memory trace. This binding process, known as pattern integration, allows the brain to recall an experience as a single event rather than as disconnected fragments. When you later remember the melody, the memory may also bring with it the light in the room, the expression on someone's face, or the feeling of warmth in the air. This unifying function explains why the hippocampus is so deeply involved in spatial memory and navigation. Within its structure lie specialized cells known as place cells, which activate when an individual occupies or visualizes a specific location. Alongside them are grid cells in neighboring regions that create an internal coordinate system, mapping environments with remarkable precision. These networks work together to build mental maps of space, enabling humans and animals alike to remember where they are, where they have been, and how to find their way. In a sense, the hippocampus not only helps us navigate the physical world, but also provides the mental landscape through which we navigate the past. The process of encoding and consolidation within the hippocampus is not instantaneous. When information first arrives, it exists as a pattern of electrical activity, fragile and easily disrupted. Through repetition and rest, particularly during sleep, these patterns are replayed and reinforced. This replay, sometimes referred to as hippocampal reactivation, occurs during slow-wave sleep and even within the brief pauses of waking rest. The hippocampus quietly rehearses the day's experiences, strengthening connections between neurons until the memory is transferred to the cortex for long-term storage. It is during this time that learning deepens and experiences take root as lasting knowledge. Neuroscientists have observed that during deep sleep, the hippocampus and cortex engage in a rhythmic exchange of signals. Waves of electrical activity pass between them, echoing the patterns formed during waking experience. This rhythmic coordination, often described as a conversation between the two regions, serves as the brain's nocturnal rehearsal, a quiet symphony of remembering. As the hippocampus replays the encoded information, cortical circuits respond by forming stable patterns of their own, ensuring that the memory can later be accessed without the hippocampus's direct assistance. Over time, the memory becomes independent, woven seamlessly into the brain's broader tapestry of understanding. Emotion plays an intimate role in this process. The hippocampus shares close connections with the amygdala, the small almond-shaped structure that governs emotional intensity and significance. When an event carries strong emotional weight, joy, fear, sorrow, or wonder, the amygdala signals the hippocampus to mark it as important. This emotional tagging enhances encoding. It is why we remember our happiest days and our most painful moments with striking clarity, while countless neutral details fade into the background. In evolutionary terms, this connection serves survival. Remembering emotionally charged events helps us learn what to seek and what to avoid. The hippocampus is also remarkable for its ability to generate new neurons throughout life, a process called neurogenesis. While most brain regions rely on existing cells, the hippocampus continues to produce new ones, particularly in an area known as the dentate gyrus. These newborn neurons are thought to contribute to learning and memory flexibility, allowing the brain to adapt to new environments and experiences. Exercise, enriched surroundings, and restful sleep have all been shown to promote hippocampal health, while chronic stress and sleep deprivation can hinder it. The balance between creation and decay within this region mirrors the delicate balance of memory itself, the constant renewal of the past through the learning of the present. The hippocampus does not store memories permanently but acts as a temporary staging area, holding them until they can be distributed across the cortex. Once a memory has been consolidated, the hippocampus's role in recalling it diminishes. Yet during retrieval, the hippocampus may still assist, acting as a cueing mechanism to reassemble the pattern. When you recall a distant memory, the smell of the sea from a childhood holiday, the color of a room long forgotten, the hippocampus helps coordinate the reactivation of cortical regions that once participated in that experience. Each time a memory is recalled, it is subtly re-encoded, shaped anew by the present context and emotion. Thus, the hippocampus is not only a recorder but also an editor. In this way, remembering is not a passive replay but an active reconstruction. The hippocampus rebuilds the scene using the fragments it once helped to bind, weaving together the sensory, spatial, and emotional threads into something coherent. Sometimes, in this reconstruction, details shift or fade. Others grow more vivid. Memory, therefore, is not fixed but fluid, a living narrative, continually revised by the mind that holds it. This creative flexibility allows us to learn from the past. As night falls and the world quiets, the hippocampus remains awake, sorting through the day's experiences. It decides, unconsciously, what to keep and what to let go. Trivial details dissolve, while moments of significance are carried forward into deeper layers of storage. The process is gentle, almost imperceptible, yet profoundly essential. By morning, the architecture of your mind has changed, new connections formed, new memories integrated. The hippocampus, though small, has reshaped the landscape of who you are. In this stillness, as the body rests and the mind drifts, the hippocampus hums softly, like a librarian working late into the night. It places each experience in its proper place, links new knowledge to old, and ensures that the story of the self continues without interruption. The next time you wake and recognize your own reflection, recall a friend's name, or remember a familiar path, it is this quiet structure to thank, for within its curved chambers, the present becomes the past, and the fleeting moment becomes something enduring, a memory, preserved within the gentle vault of the human mind. 6. The cerebral cortex and memory storage. Spread like a vast landscape across the surface of the brain, the cerebral cortex is the quiet library where human memory ultimately resides. It is the seat of awareness, the outermost layer of gray tissue folded and furrowed to fit within the skull, containing billions of neurons interwoven into patterns of immense complexity. Here, knowledge, experience, and perception are gradually woven together into the enduring fabric of understanding. While the hippocampus is the architect that drafts and organizes new memories, the cortex is the archive where those memories come to rest. It holds not just facts and words, but sensations, skills. The cortex is divided into 4 primary lobes: frontal, parietal, temporal, and occipital, each with its own specialization, yet none working in isolation. Within these folds lies the collective record of a lifetime. Every smell ever recognized, every song once learned, every face that once brought a smile, all find their resting place here in diffuse networks of neural activity. Unlike a filing cabinet where information is neatly labeled and stored, the cortex distributes memories across wide regions. Each fragment of an experience is stored where it was first processed. The visual details in the occipital lobe, the sounds in the temporal lobe, the tactile sensations in the parietal regions, and the emotional hues in deeper limbic circuits. A single memory, therefore, exists not as a single location, but as a constellation of connections spread across the mind's vast terrain. When the hippocampus first encodes a memory, it sends signals outward to the cortex, establishing links between the sensory and conceptual elements involved. Over time, As these connections are replayed and reinforced, the hippocampus's guiding hand gradually recedes. The cortex assumes the memory as its own, embedding it into long-term networks where it can persist for years, even decades. In this way, memory becomes distributed and resilient. Even if one region suffers damage, fragments of the experience may still be retrieved through the pathways that remain intact. It is a system designed for endurance, one that values integration over isolation. The cortical storage of memory reflects the principle of association. No memory stands alone. Each is bound to countless others through overlapping neural patterns. The memory of a childhood home, for instance, might be connected to the smell of rain, the sound of a parent's voice, and the feel of sunlight through a window. When one element is triggered, perhaps a scent or a melody, it can awaken the entire network, summoning the past in vivid detail. This associative structure explains the phenomenon of recall through cues. The cortex does not play memories back like a recording, but rebuilds them piece by piece, activating the distributed network that once gave rise to the experience. This process of reactivation gives memory its living, fluid quality. Each time a memory is retrieved, it is not merely recalled, but subtly rewritten. The brain's plasticity, the capacity for neurons to form and reform connections, ensures that every act of remembering slightly alters the original trace. In this sense, the cortex functions as both the library and the workshop of the mind. It holds the archives of the past while continually revising them in light of new experience. Over years, this gentle reshaping allows knowledge to grow richer and more integrated, linking old insights with new understanding. The frontal lobes, particularly the prefrontal cortex, play a central role in this orchestration. They manage the retrieval and organization of memories, guiding which details are brought into consciousness and which remain dormant. This executive function gives memory its purpose and direction. When you search your mind for a name or recall the steps of a familiar task, it is the prefrontal cortex that coordinates the search, filtering through vast cortical networks to find the relevant connections. It also integrates emotion and reasoning, ensuring that memories are not recalled in isolation but in ways that serve current needs. Meanwhile, the temporal lobes, especially their medial regions, act as repositories for auditory and linguistic information. They hold the words of language, the tones of music, and the voices that populate recollection. The parietal lobes contribute the spatial and sensory dimensions, how objects feel, where they are located, how the body relates to them in space. The occipital lobes, positioned at the back of the head, preserve visual imagery, allowing the mind to reconstruct scenes and faces with astonishing detail. Together, these regions create a unified experience when a memory is called forth. What was once fragmented across space and time becomes whole again in consciousness. The act of remembering, therefore, is a process of reconstruction that occurs across the entire cortical landscape. When a cue is presented, a sound, a smell, a phrase, the hippocampus and other subcortical structures send signals that awaken related regions of the cortex. These areas begin to fire in synchrony, re-establishing the pattern that once represented the original event. The brain does not replay a recording, it reimagines the moment. The vividness of this reconstruction depends on how strongly the original network was formed and how frequently it has been revisited. Repetition strengthens the connections, making recall easier and more accurate, while neglect allows them to fade. Over a lifetime, the cortex becomes the repository of both explicit and implicit memory. Explicit memories, also known as declarative memories, are those that can be consciously recalled facts, names, stories, and experiences. Implicit memories, in contrast, operate beneath awareness. They guide behavior and perception through habits, emotional responses, and learned skills. When you ride a bicycle, type on a keyboard, or reach instinctively for a familiar tool, You are drawing upon implicit memory stored within the cortex and its connected regions. Both forms coexist, shaping how the mind responds to the present through the quiet influence of the past. In the layered folds of the cortex, patterns of activity form the physical basis of knowledge and identity. Yet these patterns are not fixed. The brain's synapses are continually adjusting, strengthening through use and weakening through disuse. This adaptability, known as synaptic plasticity, is the essence of learning. Each new experience subtly modifies existing networks, either reinforcing old pathways or creating new ones. The cortex, in this sense, is a living landscape, a field of connections in perpetual transformation. The more an experience is recalled or practiced, the more deeply it becomes etched into the neural fabric, eventually requiring less effort to retrieve. Emotion gives this process depth and color. The limbic system, though nested beneath the cortex, communicates constantly with it, ensuring that memories are not merely cognitive but affective. The prefrontal cortex evaluates these emotional signals, helping the mind balance reason and feeling in both recall and decision. This integration is what gives human memory its richness. A recollection is not just an image or a sound. It carries warmth, nostalgia, joy, or sorrow. These emotional undertones make certain memories endure while others fade quietly into abstraction. Sleep again plays a crucial role in consolidating cortical memory. During deep stages of rest, waves of neural activity sweep across the brain, reactivating patterns that were first established during waking experience. The hippocampus communicates with the cortex, replaying sequences of activity that represent newly acquired information. This rhythmic exchange helps transfer temporary traces into stable cortical networks. By morning, the brain has reorganized itself, distilling what was once transient into something lasting. The process is seamless and silent, taking place in the background of slumber, but its effects are profound. As we age, the cortex continues to evolve, retaining its capacity for learning while selectively pruning connections that are no longer needed. This balance of plasticity and efficiency allows the mind to remain adaptable. Even in later life, new experiences can reshape cortical networks, proving that learning and growth never cease. The memories that define a person, language, culture, personal history reside here, layered upon one another like sediment, each experience leaving a trace that contributes to the whole. When you recall a familiar place, the cortex reawakens the map of that space in the parietal lobes, the colors and forms in the occipital regions, the sounds in the temporal areas, and the emotions through connections to the limbic system. All these pieces converge into a unified sense of being there once more. It is through this integration that memory becomes experience again, allowing the past to live vividly within the present, in quiet moments. As the mind drifts between wakefulness and rest, the cortex hums softly with the echoes of a lifetime's impressions. Each thought, each recollection, stirs faint ripples across its surface, reactivating pathways carved long ago. The cortex does not merely hold memory, it is memory, a living record of the countless moments that have shaped awareness. Within its folds lie the traces of learning, the essence of identity, and the continuity of consciousness itself. And so, as the day's experiences settle and the body yields to rest, the cortex continues its silent work. It organizes, strengthens, and preserves the patterns of thought that define who we are. Every night, it rewrites the self in the language of neurons and light, ensuring that the story of existence endures one gentle spark at a time. 7. The transition from short-term to long-term memory. Between the fleeting spark of experience and the enduring glow of remembrance lies one of the brain's most remarkable transformations, the conversion of short-term impressions into long-term memory. This process, known as consolidation, is what allows a single moment to persist beyond the instant it occurs. It is the quiet alchemy of thought, turning the ephemeral into the lasting, the immediate into the remembered. Without it, every experience would fade as soon as it was perceived, and life would become a series of disconnected moments, endlessly new, yet without continuity. At the heart of this transformation is time. The mind does not record memories instantly, but rather through a gradual strengthening of connections among neurons. When an experience first takes place, it creates a pattern of electrical activity across networks in the brain. These networks, composed of countless synapses, represent the temporary storage of short-term memory. They are fragile and easily disturbed, dependent on ongoing neural activity to remain alive. If that activity ceases, if attention drifts, or the thought is interrupted, the pattern dissolves. To become lasting, it must be reinforced through repetition, emotion, or the subtle processes that unfold during rest and sleep. The hippocampus acts as the master coordinator of this conversion. It receives input from across the sensory cortices, the sights, sounds, words, and feelings that make up an event, and binds them into a coherent whole. For a time, the hippocampus maintains these connections, repeatedly activating them in the same sequence, as though rehearsing the memory. Each rehearsal strengthens the synaptic bonds through a mechanism known as long-term potentiation. This process, discovered in the 20th century, is often described as the cellular foundation of learning. When two neurons communicate frequently, the efficiency of their connection increases, making it easier for signals to pass between them in the future. It is through this gradual reinforcement that a short-term trace begins to take root. The brain does not consolidate all information equally. Attention, meaning, and emotion act as filters, determining which experiences are deemed important enough to preserve. Events that evoke strong emotional responses, joy, fear, awe, are far more likely to transition into long-term memory. The amygdala, in close communication with the hippocampus, helps assign this emotional weight. When an experience carries significance, the amygdala signals the hippocampus to strengthen its encoding, ensuring that the event will not be easily forgotten. In this way, emotion serves as a sculptor of memory, carving lasting impressions from the raw material of perception. Repetition is another vital factor. Each time information is revisited, whether through active rehearsal or unconscious reactivation, the neural pathways involved are reinforced. This is why learning requires practice. A student memorizing a poem, a musician perfecting a melody, or a child mastering a new skill, all rely on this principle. Through repetition, what was once effortful becomes effortless, as the neural circuits responsible grow more stable and efficient. Over time, the hippocampus transfers the responsibility for storage to the cortex, where the memory becomes integrated with existing knowledge and can be accessed independently. Sleep provides the ideal environment for this transfer. The hippocampus and cortex engage in a quiet dialogue, exchanging information through rhythmic waves known as sleep spindles and slow oscillations. These waves coordinate the timing of neuronal firing, allowing temporary traces in the hippocampus to be reactivated and copied into long-term cortical networks. It is a subtle, nocturnal rehearsal in which the mind organizes its experiences, deciding what to keep and what to release. This is why a good night's sleep so often brings clarity and understanding. The brain has literally rewritten itself overnight. The act of consolidation is not confined to sleep. However, even during wakefulness, the hippocampus periodically replays recent experiences, especially during moments of quiet reflection or rest. This spontaneous reactivation helps solidify learning, allowing the brain to reinforce connections without conscious effort. It is during these calm interludes, when the mind is at ease, free from distraction, that memory deepens. One might think of it as the mind breathing, inhaling experience and exhaling understanding. The gradual nature of consolidation means that memories remain malleable for a time. During this window, known as the labile phase, they can be strengthened, altered, or even erased. New information that conflicts with the original can reshape the memory, integrating it into a broader context or changing its meaning entirely. This fluidity gives human memory its adaptive quality. It allows the past to evolve as new knowledge is gained, ensuring that our understanding of experience remains aligned with the present. Yet it also introduces imperfection. Recollections are not fixed recordings but living reconstructions, colored by time and interpretation. As a memory matures, its dependence on the hippocampus diminishes. The connections among cortical regions become self-sustaining, allowing recall to occur without the hippocampus's direct involvement. This process, which may take days, weeks, or even years, represents the final stage of consolidation systems. Consolidation. The once fragile pattern has become part of the brain's enduring architecture, stored among the countless others that define personal identity. It can now be accessed, reactivated, and incorporated into new memories. Long-term memories differ from short-term ones not only in duration but also in structure. While short-term memory relies on persistent neural firing, long-term memory is maintained through changes in the strength and number of synaptic connections. The proteins within neurons are altered, new dendritic spines form, and entire networks reorganize to accommodate the new information. These physical changes, though microscopic, are the embodiment of learning itself. Each experience leaves a trace within the brain's material fabric, a tangible imprint of consciousness upon matter. The brain's remarkable plasticity allows this transformation to occur throughout life. Even in adulthood, new connections can form, and existing ones can be refined. Repetition, engagement, and emotional depth remain the keys to lasting learning. In contrast, neglect and distraction weaken the neural bonds, allowing memories to fade. Forgetting, therefore, is not a failure, but a form of pruning, a necessary part of maintaining balance. The brain releases what it no longer needs, preserving clarity and adaptability for new experiences. The transition from short-term to long-term memory is thus a delicate equilibrium between remembering and letting go. It is shaped by what we value, what we repeat, and what we feel. Every person's memory is unique, not because the underlying mechanisms differ, but because the filter through which experience passes, the sum of attention, emotion, and meaning, is distinct for each life. The mind remembers what matters most to it, often in ways that logic cannot predict. As evening deepens and the body drifts toward rest, this quiet work of transformation continues. The hippocampus replays the day's patterns in gentle bursts, each wave strengthening a connection, each pause releasing what is no longer needed. The cortex listens, absorbs, and adapts, reshaping itself in response. By morning, the mind is subtly changed, its architecture refined, its understanding deepened. A fleeting conversation, a melody, a fragment of thought, each has either faded or taken root, determined by the unseen choices of the sleeping brain. In this nightly rhythm of retention and release, the mystery of memory reveals itself as both biological and poetic. It is a process that unites the living tissue of the brain with the intangible flow of consciousness. Every long-term memory, no matter how simple or profound, began as a flicker in short-term awareness, a passing spark that the hippocampus chose to nurture. And as you close your eyes tonight, your mind will continue that ancient ritual, preserving the essence of who you are through the quiet work of time and thought. 8. Long-term memory, the library of the self. Long-term memory is the deep reservoir of the human mind, the vast and silent library where all that has been learned, seen, and felt finds its resting place. It stretches beyond the limits of immediate awareness, preserving the experiences that give life continuity and meaning. Within it lies the story of a person's existence, the language they speak, the faces they know, the knowledge they carry, and the emotions that have shaped their journey. Unlike the fleeting patterns of short-term and working memory, long-term memory endures across time, sometimes for a lifetime. This enduring form of memory is not stored in a single place. nor is it uniform in nature. It is a living network spread across the cortex and the deeper structures of the brain, intricately layered and endlessly adaptive. Each type of long-term memory serves a different function, and together they weave the tapestry of identity. Some memories are explicit, meaning they can be consciously recalled. Others are implicit, operating quietly beneath awareness, guiding behavior through habits, skills, and emotional responses. The coexistence of these systems allows the mind to function effortlessly, recalling the information it needs while relying on instinct and learned behavior to manage the rest. Explicit memory, often called declarative memory, encompasses what we can consciously describe and recall. It divides further into episodic and semantic memory. Episodic memory is autobiographical. It holds the recollections of personal experiences, complete with time, place, and emotion. It is what allows you to remember your first day at school, the smell of your grandmother's kitchen, or the sound of laughter on a warm summer evening. These memories are vivid because they are rooted in context. They carry the sensory and emotional details that make them uniquely yours. The hippocampus plays a central role in forming and retrieving these memories, working alongside the cortex to reconstruct the scenes of the past whenever they are recalled. Semantic memory, by contrast, contains the knowledge of facts, concepts, and meanings that are not tied to specific experiences. It is what allows you to know that Paris is the capital of France, that water boils at 100 degrees Celsius. These memories are built gradually through exposure and learning, stripped of the emotional context that characterizes episodic memory. Over time, the hippocampus helps transfer these learned facts into the neocortex, where they become deeply embedded and readily accessible. It is through semantic memory that humanity builds collective knowledge, the foundation upon which language, science, and culture are constructed. Implicit memory, or non-declarative memory, operates in the background, influencing behavior without conscious awareness. It encompasses procedural memory, the learning of skills and habits, as well as conditioning and emotional responses. Riding a bicycle, typing on a keyboard, or playing an instrument all rely on procedural memory. Once these actions are learned, they no longer require deliberate thought. The basal ganglia and cerebellum, rather than the hippocampus, are primarily responsible for their storage and execution. This division of labor within the brain ensures efficiency. Complex physical tasks can be performed automatically, freeing conscious thought for new challenges. Another form of implicit memory resides in the emotional domain. The amygdala, closely linked to the hippocampus, helps store the emotional significance of experiences. When a particular sound, smell, or image evokes a sudden wave of feeling, it is the amygdala at work, reawakening the affective trace of a past event. Emotional memory gives human experience its depth, coloring recollection with warmth, fear, nostalgia, or joy. It is this emotional resonance that allows memories to influence behavior long after the original events have faded from conscious recall. The strength and persistence of long-term memory arise from the physical changes it creates within the brain. When an experience is consolidated, the connections between neurons, called synapses, are strengthened through chemical and structural modifications. This process, known as synaptic plasticity, is the biological basis of learning. Over time, groups of neurons form stable networks that can be reactivated whenever a memory is recalled. These networks can endure for decades, though they are never truly static. Each act of remembering subtly modifies the original pattern, integrating new information or reshaping the emotional tone. In this way, long-term memory is not a perfect archive, but a living, evolving record that grows and changes alongside the person who carries it. The capacity of long-term memory is virtually limitless. The human brain contains an estimated 86 billion neurons, each forming thousands of connections. The number of possible combinations is so vast that it exceeds comprehension, suggesting that the mind's ability to store experience has no measurable ceiling. Yet, despite this abundance, memory remains selective. Not every event is preserved. Only those that capture attention, meaning, or emotion are likely to endure. This selectivity is what allows the mind to remain clear and functional, retaining the essential while letting the trivial fade away. Retrieving information from long-term memory is a process of reactivation. When a cue, a word, a sound, a familiar scene triggers the corresponding network, the brain reconstructs the memory by reassembling its distributed components. The hippocampus often plays a role in this reactivation, especially for episodic memories that require rich contextual detail. For semantic knowledge or procedural skills, the cortical and subcortical regions take over, drawing directly upon their specialized circuits. The ease of retrieval depends on the strength of the connections and the presence of cues that guide the search. This is why certain memories return effortlessly, while others remain elusive until something, a scent, a melody, a passing phrase, brings them back to light. Forgetting, though often seen as a failure of memory, is an essential aspect of this system. The brain's capacity to forget allows it to adapt, discarding information that is outdated or irrelevant. The fading of memories occurs through a combination of synaptic weakening and interference from new learning. Just as repetition strengthens connections, disuse allows them to decay. Over time, this gentle erosion ensures that the mind remains flexible, ready to form new memories without being overwhelmed by the weight of the old. In some cases, forgotten memories are not truly lost, but simply inaccessible, their pathways dormant, until the right cue reawakens them. Emotion continues to play a powerful role in the persistence of long-term memory. Events charged with feeling are encoded more deeply and resist decay more effectively. The amygdala's influence ensures that such memories remain vivid, often resurfacing spontaneously. This mechanism, though adaptive, can also give rise to unwanted recollections, traumas, and fears that linger despite efforts to forget. The same neural pathways that preserve joyful experiences also secure painful ones, a reminder that memory serves not only pleasure, but survival. Across the years, long-term memory forms the foundation of identity. Each recollection, each fragment of knowledge, contributes to the ongoing narrative of the self. Without memory, there would be no continuity, no sense of who we were yesterday or who we might be tomorrow. It is through long-term memory that we recognize the world and our place within it. It holds the language through which we think, the skills through which we act, and the wisdom accumulated through experience. It is not a separate faculty, but the essence of consciousness itself, the bridge between perception and reflection, between living and understanding. In the quiet hours of rest, as the mind drifts between waking and sleep, the vast library of long-term memory remains active beneath awareness. It organizes, cross-references, and subtly edits its contents, weaving new experiences into the existing framework. Even in dreams, traces of memory reappear, mingling with imagination in fluid, symbolic form. The brain never ceases its work. It is always learning, always integrating, always refining the story it tells itself. And when morning comes, that story continues seamlessly. You awaken, already surrounded by memory, the knowledge of who you are, where you are, and what the world around you means. You do not have to relearn the language you speak or rediscover the faces of those you love. All of it is there, carried quietly within the networks of your mind. Long-term memory is the silent companion that preserves continuity through the flow of time, ensuring that life is not merely a succession of moments, but a coherent and meaningful journey. It is the library of the self, vast and luminous, filled with the endless pages of experience, each one written in the delicate script of the human brain. 9. Episodic and semantic memory. Within the great expanse of long-term memory, two closely related systems work together to hold the substance of human experience. They are episodic and semantic memory. and though they share the same neural architecture, their purposes are beautifully distinct. Episodic memory is the memory of experience, the personal story of life as it unfolds through time. Semantic memory, on the other hand, holds the knowledge of the world, the facts, meanings, and understandings that form the scaffolding of thought. Together, they shape how we remember, how we learn, and how we make sense of existence. They give texture and coherence to consciousness, ensuring that memory is not only a record of what has been lived, but also a framework through which we interpret what we encounter. Episodic memory might be thought of as the diary of the self. It holds the moments that belong to you alone, the afternoon sunlight falling through a window from years ago, the laughter of a friend in a quiet cafe, the scent of rain when you were young. Each episode is grounded in context, tied to time, place, and emotion. When you recall an episodic memory, the mind does not simply retrieve information. It reconstructs the moment, reawakening the sensations, images, and feelings that once surrounded it. You may not remember every detail with precision, but the essence of the experience, its emotional temperature, its rhythm, its atmosphere, returns with a gentle clarity. These are the memories that remind you that your life has been a continuous journey through time, filled with moments that, though gone, still live quietly within you. The hippocampus plays a central role in the formation of episodic memory. Acting as a bridge between perception and storage, it binds together the many elements that make an experience whole. Each sight, sound, and sensation travels along its own neural pathway to the hippocampus, where they are fused into a single memory trace. Over time, as these connections are replayed and strengthened, the memory becomes integrated into the cortical networks of long-term storage. This binding function explains why the hippocampus is so critical for creating new memories. When it is damaged, as in certain forms of amnesia, the ability to form new episodes is lost, leaving a person suspended in an eternal present, able to recall the past but unable to add to it. Episodic memory is unique in that it carries a sense of self within it. When you recall a moment from your life, you do not simply remember the event. You re-experience it from your own perspective. Psychologists refer to this as autonoetic consciousness, the awareness of oneself as a participant in time. This self-reflective quality allows you to mentally travel backward, revisiting events with a kind of inner vision. The same ability also enables you to project forward, imagining possible futures using the material of past experience. In this way, episodic memory serves not only as a record of life, but as a foundation for planning, creativity, and empathy. Semantic memory, by contrast, is detached from personal experience. It is the knowledge that remains when the context of learning has faded, the accumulation of facts, concepts, and meanings that structure thought. It holds the understanding that the earth orbits the sun, that poetry is made of words, that a rose is a flower. These facts exist independently of the circumstances in which they were learned. You might not remember who first taught you that Paris is the capital of France, or where you first encountered the concept of gravity. Yet this knowledge endures, ready to be summoned whenever needed. Semantic memory gives the mind its stability. It is the shared framework of understanding that connects individual experience to the collective knowledge of humanity. While episodic and semantic memory serve different functions, they are deeply intertwined. Most semantic knowledge begins as episodic experience, something learned, read, or observed in a particular moment. Over time, as the context fades and the knowledge is reinforced through use, it becomes abstracted, stripped of its original setting, and stored as semantic memory. For example, you might remember vividly the day you first learned to multiply numbers, recalling the classroom and the sound of your teacher's voice. Years later, the knowledge of multiplication remains, but the details of that day may have vanished. The episodic has become semantic, the specific transformed into the universal. This gradual transformation shows how the two systems work in harmony, ensuring that knowledge is both personal and enduring. Neuroscientific research suggests that these two forms of memory rely on overlapping but distinct networks within the brain. The hippocampus and adjacent medial temporal structures are essential for episodic memory, particularly during its initial encoding and retrieval. The frontal lobes, meanwhile, play a key role in organizing and retrieving these memories, guiding attention and determining relevance. Semantic memory depends more heavily on the lateral temporal cortices, which store conceptual knowledge, and on the prefrontal areas that help integrate this knowledge into reasoning and language. Though they share pathways, the way these systems communicate determines whether a memory is remembered as a personal episode or understood as general knowledge. Emotion colors both episodic and semantic memory, but in different ways. In episodic recall, emotion is part of the experience itself. The hippocampus works closely with the amygdala to store not only the event but its feeling tone. This is why certain memories come alive with such clarity, why a single song can transport you back to a moment filled with joy or sorrow. Semantic memory, though less emotional, is still shaped by value and meaning. Facts that resonate with personal interest or importance are more likely to be remembered. The brain remembers best what it finds relevant, binding emotion to information in subtle ways that enhance learning. The passage of time affects episodic and semantic memory differently. Episodic memories are more vulnerable to fading, as the contextual details that define them gradually weaken. Semantic memory, being more abstract, is more stable, often persisting even when the events that gave rise to it have been forgotten. This distinction becomes evident in aging. Older adults may find it difficult to recall specific events, but can retain knowledge and vocabulary accumulated over decades. The wisdom that often accompanies age arises in part from this balance. As the vividness of episodic detail softens, the depth of semantic understanding grows, giving perspective to experience. Memory retrieval in both systems is an act of reconstruction. When recalling an episodic event, the brain reassembles its components, the visual imagery from the occipital lobe, the sounds from the temporal lobe, the emotions from the amygdala, into a unified experience. When recalling semantic knowledge, it activates the networks of language and concept, reawakening the meanings stored within them. In each case, recall is not a playback but a recreation, influenced by the present state of mind, the current environment, and the associations that emerge in the moment. This plasticity gives memory its richness but also its fallibility. Recollections are colored by interpretation, reshaped by context, and woven into the ever-changing narrative of the self. Both episodic and semantic memory benefit profoundly from sleep. During the night, the hippocampus replays patterns of neural activity linked to recent experiences. For episodic memory, this means the preservation of context and emotional tone. For semantic memory, it strengthens the abstraction of knowledge from experience. It is during these silent hours that learning becomes permanent, as the fragile traces of the day are transformed into enduring structures of thought. Together, these two systems, one personal and emotional, the other impersonal and intellectual, form the foundation of human cognition. Episodic memory provides depth and identity. Semantic memory provides structure and meaning. One tells the story of who we are. The other explains the world we inhabit. They are like two sides of a single coin, inseparable and mutually sustaining. Without episodic memory, life would lack continuity, a blur of disconnected facts without a narrative thread. Without semantic memory, experience would be unanchored, rich in feeling, but devoid of understanding. In the quiet workings of these twin systems lies the essence of what it means to be human. Every thought you have, every word you understand, every moment you recall is built upon their partnership. As you rest tonight, they will continue their silent dialogue, the hippocampus, whispering stories of the day, to the cortex distilling knowledge from those stories into something enduring. By morning, What was once fleeting will have found its place within the library of the mind. Another page added to the story of self, another fact woven into the fabric of understanding. 10. Procedural memory and the basal ganglia. Beneath the surface of conscious thought, where the mind ceases to speak in words and deliberate recall, there lies a quiet and enduring form of memory that guides movement, skill, and habit. This is procedural memory, the body's way of remembering. It is the reason you can ride a bicycle after years without practice, type effortlessly on a keyboard, or find your fingers forming familiar chords on a piano without a single conscious instruction. Unlike the episodic and semantic memories that live in awareness, procedural memory operates silently, rooted deep within the neural circuits that govern motion and routine. It is the memory of doing, the knowledge that flows through the body rather than the tongue. The foundation of procedural memory resides in the basal ganglia, a collection of interconnected structures situated near the center of the brain. These clusters of neurons work in concert with the cerebellum and motor cortex to coordinate movement, timing, and habit formation. While the hippocampus encodes the experiences that shape the story of life, the basal ganglia encode the patterns of repetition that allow the body to act without thought. Together, they form the quiet machinery of mastery. Every skill, from walking to writing, begins with conscious effort, but through repetition and refinement, it is gradually transferred from the fragile circuits of working memory into the deep, resilient systems of the basal ganglia. Learning through repetition is one of the most fundamental processes of the human brain. When you first attempt a new skill, say, learning to play a musical instrument, the prefrontal cortex and hippocampus are highly active. You must think carefully about each movement, translating instruction into action. The process feels slow, deliberate, and often clumsy, but with continued practice, the burden of control shifts. The neural circuits in the basal ganglia begin to take over, recognizing patterns and automating them. The activity of the prefrontal cortex decreases, freeing conscious thought for other tasks. Eventually, the skill becomes effortless. The hands remember what the mind no longer needs to direct. This transformation from conscious learning to automatic execution is the hallmark of procedural memory. The basal ganglia accomplish this through their remarkable ability to detect and reinforce patterns of behavior. They are composed of several interconnected regions: the caudate nucleus, putamen, globus pallidus, and substantia nigra, each contributing to the refinement of movement and the reinforcement of successful actions. When a sequence of behavior leads to a desired outcome, the basal ganglia strengthen the neural connections that produced it. This process is guided by the neurotransmitter dopamine, which signals reward and satisfaction. Each time a correct movement or decision is made, dopamine reinforces the associated neural pathway, making it more likely to be activated again. Over time, the pattern becomes habitual, embedded deeply within the circuitry of the brain. This system of reinforcement allows procedural memory to function with remarkable efficiency. It not only governs physical skills, but also underlies habits, routines, and even certain forms of thought. The morning rituals that unfold without conscious planning, the automatic gestures of driving or tying shoes, all are guided by the basal ganglia. These patterns emerge from countless repetitions, sculpted gradually through the feedback of experience. Once established, they require little conscious oversight. Indeed, it can be difficult to unlearn them, for the very efficiency that makes procedural memory reliable also makes it resistant to change. The cerebellum, located at the back of the brain beneath the occipital lobes, plays a complementary role. It fine-tunes movement, ensuring precision and coordination. While the basal ganglia determine which patterns of action to execute, the cerebellum ensures that those actions unfold smoothly. It compares intended movement with actual performance, making subtle corrections in real time. This partnership between the basal ganglia and cerebellum creates the fluid grace of skilled motion, from the steady hand of a surgeon to the dancer's effortless poise. Through repetition, The cerebellum stores sequences of movement, allowing them to be recalled automatically when needed. Procedural memory is deeply tied to emotion and motivation, not through the vivid feelings of episodic recall, but through a quieter form of satisfaction. The small surges of dopamine that accompany successful performance reinforce learning and create the intrinsic pleasure of mastery. This is why repetition, though monotonous, can also be rewarding. Each cycle of improvement brings a subtle sense of accomplishment, encouraging further practice. In this way, procedural memory shapes not only behavior but character, fostering persistence, patience, and confidence through the steady rhythm of repetition. Unlike declarative memory, procedural memory is remarkably durable. Once a skill is learned, it tends to remain intact even after years of disuse. The pathways that encode procedural knowledge are less susceptible to decay because they rely on structural changes in deep brain circuits, rather than the fragile patterns of cortical activation that support conscious recall. Even in cases of amnesia, where the hippocampus is damaged and new declarative memories cannot be formed, they may forget having practiced a task, yet their performance improves each time, guided by the unseen hand of procedural learning. This distinction highlights the independence and resilience of the system the body remembers, even when the conscious mind does not. Habits, too, are a form of procedural memory, though they exist at the boundary between motor behavior and cognition. They emerge through repetition and reinforcement, shaped by context and reward. Each time a behavior is performed in a particular situation, the association between the context and the action grows stronger. Eventually, the cue alone can trigger the behavior, bypassing conscious decision-making. This mechanism is adaptive, conserving mental energy for more complex tasks. Yet it also explains why habits, both good and bad, can be difficult to change. The neural circuits that sustain them are carved deep, resistant to erasure. To form a new habit, the brain must gradually build an alternative pathway, reinforced by consistency and reward, until it becomes the dominant pattern. The influence of procedural memory extends beyond the physical realm. It underlies linguistic fluency, social behaviors, and creative expression. When a poet writes, when a musician improvises, or when a speaker finds the right words without pause, the act may feel spontaneous, but it draws upon countless repetitions stored in the neural fabric of experience. In this way, procedural memory connects the mechanical with the expressive, turning practice into art. Sleep, once again, plays a crucial role in the consolidation of procedural memory. During specific stages of rest, particularly during deep, slow-wave sleep and REM sleep, the brain replays the patterns of neural activity involved in recent learning. This rehearsal strengthens the connections within the basal ganglia, cerebellum, and motor cortex, refining the skill even in the absence of conscious practice. It is why a musician may find improvement after a night's rest, or why a task that felt clumsy one day can seem smoother the next. The brain, in its quiet hours, continues to learn, polishing the patterns of the day into lasting memory. Procedural memory gives the mind its foundation of fluency and efficiency. It allows life to flow smoothly, freeing consciousness from the burden of constant decision-making. It is the quiet current beneath awareness, carrying forward the knowledge of movement, rhythm, and habit that defines daily life. Every practiced action, from the graceful motion of handwriting to the subtle timing of conversation, owes its ease to the enduring labor of the basal ganglia and cerebellum. As you rest tonight, this ancient system remains active, replaying the patterns of your movements and routines, refining them in silence. The hippocampus may dream in stories, but the basal ganglia dream in rhythm, in the repetition of motion and sequence, in the perfecting of coordination and flow. It is the language of the body's memory, older than words, deeper than thought. Within it lies the continuity of skill, the quiet persistence of practice, and the grace of mastery that endures long after conscious learning has passed into instinct. 11. Emotional memory and the amygdala. There are moments in life that remain etched in the mind, with a clarity so vivid that even the passing of years cannot dull them. The trembling excitement of a first success, the soft ache of loss, the calm wonder of standing before a vast horizon. These are the moments that emotion engraves upon memory, giving it depth and endurance. Emotional memory is not simply the recollection of events. It is the reawakening of the feelings that accompanied them. It is what makes the human experience rich and textured, allowing us to remember not only what happened, but how it felt. At the heart of this delicate system lies a small, almond-shaped structure buried deep within the temporal lobes, the amygdala. The amygdala is one of the most ancient parts of the brain, a remnant of our evolutionary past that continues to shape how we perceive and remember the world. It serves as the mind's emotional sentinel, constantly evaluating stimuli for significance, alerting us to danger. Its influence reaches far beyond the fleeting emotions we consciously feel. It guides learning, decision-making, and memory formation, ensuring that experiences carrying strong emotion are not easily forgotten. The amygdala does not store memories itself. Instead, it modulates the encoding and retrieval of memories throughout the brain, especially in cooperation with the hippocampus. When something deeply affects us, whether through joy or fear, the amygdala marks it as important, amplifying the neural signals that will later ensure its persistence. This interaction between the amygdala and the hippocampus forms the foundation of emotional memory. The hippocampus organizes the contextual details of experience, the where and when, while the amygdala attaches the emotional value, determining how strongly that experience will be remembered. When the amygdala signals high emotional significance, it triggers a cascade of chemical changes, releasing neurotransmitters such as norepinephrine and dopamine. These chemicals heighten the activity of neural circuits, increasing attention and strengthening synaptic connections. As a result, emotionally charged events are encoded more deeply and recalled with greater intensity. The brain, in effect, prioritizes memories that could be vital for survival or meaning, ensuring that joy, love, and fear leave their lasting mark. The link between emotion and memory can be traced back to our evolutionary origins. For early humans, remembering emotionally significant events was crucial for survival. The amygdala's role in fear conditioning, associating a neutral stimulus with danger, allowed individuals to learn quickly which situations to avoid. A single encounter with a predator or a harmful environment could create a lifelong memory of caution. This mechanism remains active today, shaping how we respond to both physical and social threats. A harsh word, a moment of embarrassment, or a gesture of kindness can all leave deep impressions, influencing behavior long after the event has passed. Emotional memory, therefore, is both protective and instructive, teaching the mind what to seek and what to avoid. Yet emotion does more than preserve fear. It also preserves joy, love, and beauty. The amygdala responds not only to threat, but to all forms of heightened significance. When we experience something profoundly moving, a piece of music, a work of art, the smile of a loved one, the amygdala signals the brain to hold on to it. These positive emotional memories are equally vital, serving as sources of motivation, comfort, and connection. They provide resilience, reminding us of hope and pleasure even in times of struggle. Through them, memory becomes not just a record of what was endured, but a celebration of what was cherished. The persistence of emotional memory is one of its defining features. Long after the details of an event fade, the emotion it evoked can remain. You may not remember every word of a conversation, but you recall how it made you feel. Emotional arousal triggers the release of stress hormones like cortisol, which, in moderate amounts, enhance memory consolidation. However, when these hormones flood the system during extreme stress or trauma, they can have the opposite effect, distorting or fragmenting recollection. Traumatic memories often persist with painful clarity, replaying involuntarily and intrusively, as if the amygdala continues to sound the alarm long after the danger has passed. In such cases, the balance between the amygdala and the prefrontal cortex, the region responsible for regulation and reasoning, can be disrupted. The amygdala, ever vigilant, may override rational control, causing emotional memories to dominate thought and perception. This imbalance explains why certain triggers can evoke powerful reactions seemingly out of proportion to the present situation. The past, stored vividly in emotional circuits, seeps into the present. Over time, through therapy, mindfulness, and new learning, the prefrontal cortex can help recalibrate this relationship, teaching the brain that the danger or pain belongs to the past and need not define the now. The subtlety of emotional memory extends beyond fear and trauma. The amygdala interacts with regions such as the orbitofrontal cortex and the anterior cingulate cortex to interpret facial expressions, tone of voice, and social cues. Through these interactions, the brain learns to associate certain expressions or behaviors with trust, kindness, or threat. This capacity allows humans to navigate complex social worlds, forming attachments and relationships grounded in emotional understanding. It is through this same circuitry that we feel compassion, recognizing in another's suffering echoes of our own. Emotional memory, therefore, is the root of empathy, connecting individual experience to shared humanity. Sleep, once again, plays a profound role in the processing of emotional memories. During REM sleep, when dreams are most vivid, the amygdala is highly active, replaying and recontextualizing emotional experiences. The hippocampus and prefrontal cortex work together to integrate these emotions into broader memory networks, reducing their intensity while preserving their meaning. In this nocturnal workshop, the brain gently unravels the emotional weight of the day, transforming raw feeling into reflection. This process explains why, after rest, distress often softens and understanding grows clearer. It is not that the feeling vanishes, but that it is woven into the greater tapestry of the self, where it can be understood rather than simply endured. Art, music, and storytelling also draw their power from the workings of emotional memory. A song that brings tears, or a story that moves the heart, does so by resonating with the amygdala's deep associations. The rhythm, tone, and imagery awaken echoes of past feeling, blending memory with imagination. Artists, knowingly or not, speak the language of the amygdala. They engage the emotional centers of the brain to make experience unforgettable. In turn, art becomes a form of emotional rehearsal, allowing the mind to explore feeling safely, to learn empathy, and to integrate emotion with intellect. As people age, emotional memory often becomes gentler. The amygdala's reactivity diminishes slightly, and positive memories come to dominate over negative ones. This shift, sometimes called the positivity effect, may serve an adaptive purpose, helping older adults maintain well-being and perspective. Even as cognitive memory fades, the emotional tone of experiences can remain, allowing affection, gratitude, and peace to persist. The heart remembers, even when words and details are lost. This endurance of emotion is what makes human memory so beautifully complex. It is both fragile and indelible, fleeting and eternal. In the quiet chambers of the mind, the amygdala stands watch, its small shape housing the power to color every memory with feeling. It does not judge or reason. It simply responds, ensuring that the moments that move us are never entirely lost. Whether through love or sorrow, excitement or fear, emotion imprints upon memory, the pulse of life itself. And as you rest, the amygdala continues its subtle work, helping the brain integrate the day's feelings into meaning. By morning, the storm of emotion softens into calm awareness, and what remains is understanding the quiet trace of feeling transformed into wisdom. 12. Forgetting and memory decay. Forgetting is often thought of as a flaw of the human mind, a failure of memory that steals from us the precious details of our lives. Yet, in truth, forgetting is not a weakness, but an essential part of how the brain maintains balance and clarity. Without it, the mind would become cluttered with endless information, unable to distinguish what is important from what is trivial. Every moment of existence brings with it a flood of sensory input sounds, sights, words, thoughts, and emotions, and it is impossible, even undesirable, to keep them all. Forgetting is the quiet gardener of the mind, pruning away the excess so that the meaningful may thrive. It is not an erasure, but a refinement, a process that allows memory to remain alive and adaptable rather than static and overwhelming. From a biological perspective, forgetting is as natural as remembering. Memories are not stored as fixed images or recordings, but as dynamic patterns of neural connections. Each memory is distributed across networks of neurons that communicate through synapses, the tiny gaps where chemical signals pass between cells. When we recall something, the same networks that were active during the original experience are reactivated, their pathways lit once more. Over time, however, if these pathways are not revisited or reinforced, the connections between them begin to weaken. This gradual fading of synaptic strength is the essence of memory decay. It ensures that the mind remains efficient, freeing space and energy for new learning. The rate of forgetting varies depending on the nature of the memory and the emotional weight it carries. Information learned without emotional engagement or repetition tends to fade quickly, sometimes within hours or days. Emotional or meaningful experiences, by contrast, are retained much longer, anchored by the influence of the amygdala and hippocampus. The psychologist Hermann Ebbinghaus, in the late 19th century, was among the first to study forgetting systematically. Through his meticulous experiments, he described what became known as the forgetting curve, a pattern showing that memory loss is steepest soon after learning but slows over time. This curve illustrates the delicate balance between memory retention and decay, a rhythm that continues throughout life. Repetition acts as the natural antidote to forgetting. Each time a memory is recalled or rehearsed, the neural connections that represent it are strengthened, renewing their vitality. This is why practice and review are so effective for learning and why certain memories, like songs or childhood routines, remain vivid after years of repetition. Yet even repetition must be measured. Too much rigidity in memory can hinder adaptation. The brain's selective forgetting allows for flexibility, enabling old memories to make way for new associations. In this way, forgetting becomes a form of learning, a clearing of mental space for growth and change. Interference is another key factor in the fading of memory. The mind does not store each memory in isolation, but in overlapping networks where related experiences share pathways. When new information resembles something already known, the two can compete for retrieval. This is called retroactive interference, where new learning disrupts old memory. The reverse, proactive interference, occurs when existing knowledge makes it difficult to learn something new. Both forms highlight how dynamic memory truly is. It is a system of constant negotiation, where old and new experiences weave together, sometimes harmoniously, sometimes at odds. Forgetting can also occur at the level of retrieval rather than storage. Sometimes the memory remains intact but inaccessible, hidden behind the fog of distraction or the passage of time. This phenomenon, known as retrieval failure, explains why we often recognize something familiar once prompted by a cue. A smell, a word, or a melody can suddenly unlock an entire set of memories that seemed lost. The pathways were there all along, merely dormant. The hippocampus plays a crucial role in this process, serving as the index that points to where memories are stored in the cortex. When retrieval fails, it is as if the index has temporarily misplaced its reference. Emotion can both strengthen and distort memory. Chronic stress, for example, can disrupt the delicate chemistry of memory formation. Elevated levels of cortisol, the body's primary stress hormone, can damage neurons in the hippocampus, impairing both encoding and retrieval. Over time, this can lead to gaps or fragmentation in memory. Conversely, positive emotional states, such as curiosity or joy, enhance memory consolidation, allowing experiences to be remembered more clearly. The emotional balance of life thus becomes intertwined with the rhythm of remembering and forgetting, each influencing the other in quiet, intricate ways. Sleep again plays a profound role in this process. During sleep, the brain not only consolidates memories, but also prunes unnecessary connections. The slow, synchronized waves of deep sleep and the vivid dreaming of REM sleep work together to refine neural networks. Some traces are strengthened, others are weakened or erased. This nightly cleaning preserves efficiency and coherence within the brain. The next day, we awaken not only refreshed but subtly edited, our mental landscape simplified and clarified. The mind lets go of what no longer serves its purpose, preparing itself to learn anew. Forgetting also carries emotional and psychological value. To forget pain is a form of healing. To forget disappointment is to make room for hope. Memory holds the weight of experience, but forgetting lifts it. The balance between the two allows the self to move forward rather than remain trapped in the past. The poet once called memory the treasury and guardian of all things. But even the most faithful guardian must know when to release. It is forgetting that gives memory its grace, the ability to transform raw experience into wisdom rather than burden. There is a gentleness in forgetting that is often overlooked. Consider how the sharpness of grief softens with time, how anger fades into understanding, how the countless small details of days gone by blur into a single, golden impression. This is not loss, but transformation. The brain, in its quiet intelligence, allows emotion to settle, smoothing the jagged edges of recollection until only the essence remains. What endures is not every detail, but the meaning beneath them, the lesson. In this way, forgetting and remembering are not opposites but partners, shaping the human story together. In certain conditions, however, forgetting can become excessive, disrupting the sense of continuity and self. Disorders such as Alzheimer's disease and other forms of dementia gradually erode the networks that sustain long-term memory. The hippocampus and cortex lose their delicate connectivity, and the tapestry of experience begins to unravel. This loss reveals just how deeply memory and identity are intertwined. To forget too much is to lose the thread that ties the present to the past. Yet even in such decline, traces of emotional memory often remain. A familiar song or a tender gesture can still awaken recognition, suggesting that the heart remembers what the mind forgets. The process of memory decay, though often invisible, is continuous. Every day, old connections fade as new ones form. The mind is not a static repository, but a living system, perpetually balancing between remembering and releasing. This balance is essential for creativity and adaptation. If nothing were forgotten, there would be no space for new perspectives or innovation. Forgetting clears the canvas so that imagination may paint anew. It allows the self to be fluid, evolving rather than fixed. As the night deepens and thought slows, the brain continues its unseen work of selection. The experiences of the day begin to settle into their places, some strengthened, others fading softly into obscurity. The mind does not mourn what it loses. It simply lets go, confident that what matters will remain. In this nightly rhythm of remembrance and release, the brain finds its peace. Forgetting, like sleep itself, is an act of renewal, a quiet surrender that makes tomorrow possible. 13. The science of recall. To remember is to summon the past into the light of the present, to awaken dormant patterns of thought and bring them once more into awareness. The act of recall is one of the most intricate and mysterious processes in the human brain. It may feel effortless, a name retrieved, a melody remembered, a scent evoking a childhood scene. But beneath that gentle simplicity lies a vast orchestration of neural activity. Memory is never a simple replay of experience. It is a reconstruction, a careful reassembly of scattered fragments stored across the brain. Every act of remembering is also an act of creation, weaving the past anew each time it is brought to mind. The process of recall begins with a cue. A cue can be anything: a sight, a sound, a word, a feeling that triggers the reactivation of a particular neural network. The hippocampus serves as the index of memory, guiding the search through the vast library of the cortex. When a cue appears, the hippocampus identifies the pattern of connections associated with it and begins to reactivate the cortical regions where the memory's elements are stored. Visual aspects may arise in the occipital lobes, sounds in the temporal regions, sensations in the parietal areas, and emotion through the amygdala. Within moments, these dispersed fragments synchronize, and the memory comes alive in consciousness, not as a perfect replica of the original, but as a living reflection of it. This distributed nature of recall means that no memory exists in isolation. Each is connected to countless others through networks of association. When one memory is retrieved, it can bring forth others that share its pathways, a phenomenon known as spreading activation. This is why remembering one detail often triggers a cascade of related thoughts. The scent of pine might recall a forest walk, which in turn evokes the image of a loved one's laughter, which may lead to a broader reflection on that time in life. The mind moves fluidly through its web of connections, linking emotion. Because recall depends on reconstruction rather than playback, memories are never exact reproductions of experience. Each act of remembering subtly alters the memory itself, reshaping it in light of current knowledge and emotion. The neural pathways that represent a memory are reactivated and then reconsolidated, meaning they can be updated with new information before being stored again. This process allows memory to remain flexible, adapting to changing understanding. However, it also introduces error. Over time, the boundaries between remembering and imagining can blur, leading to distortions, embellishments, or omissions. Memory, though rooted in biology, is as creative as it is accurate. Emotion plays a powerful role in the act of recall. The amygdala, closely linked to the hippocampus, helps prioritize emotionally significant memories, making them easier to retrieve. When a memory carries strong feeling, its neural connections are reinforced, and even subtle cues can bring it to the surface. This is why emotionally charged moments, whether joyful or painful, are recalled with striking vividness. The rush of feeling that accompanies such recollections is not merely psychological, it is physiological, as the brain's emotional circuits are reactivated, releasing the same neurotransmitters that accompanied the original experience. Context also shapes recall. Memories are more easily retrieved when the environment or mood at the time of recall resembles that of the original experience. This principle, known as context-dependent memory, explains why returning to a familiar place can suddenly unleash a flood of recollections. The brain's networks use environmental cues as anchors, linking external details to internal states. Similarly, mood-dependent memory reflects how emotion acts as a bridge between past and present. When you feel joy, it is easier to recall joyful memories. When you feel sadness, the mind draws forth moments that resonate with that tone. In this way, recall is not just a retrieval of facts, but a harmonizing of the inner and outer worlds. Attention, too, plays a crucial role. To recall something, the prefrontal cortex orchestrates this process, directing attention toward the relevant cues while suppressing distractions. It is the executive of memory retrieval, guiding the hippocampus in its search through stored associations. When attention falters, recall weakens, and the thread of memory slips away. This is why stress, fatigue, or distraction can make recollection difficult. The neural coordination required for successful retrieval becomes disrupted. Calm and focus, on the other hand, allow the mind to trace its way through the pathways of memory with greater ease. The act of recall also strengthens memory itself. Each time a memory is brought into consciousness, it becomes more stable through a process called reconsolidation. The neural pathways are reactivated and refreshed, preventing decay and integrating the memory with newer experiences. This is why revisiting what we have learned enhances retention, a principle long understood in education and practice. Repeated recall does not merely preserve memory, it reshapes and deepens it, transforming knowledge into wisdom and experience into understanding. Not all memories are equally accessible. Some lie close to the surface, easily retrieved, while others dwell in deeper layers, requiring more effort to reach. The distinction depends on how well the memory was encoded, how often it has been recalled, and how relevant it remains to present experience. Over time, memories that are seldom retrieved become less connected to current thought and emotion, fading into the quiet background of the mind. Yet even these dormant traces can sometimes resurface unexpectedly. A scent, a sound, or a turn of phrase can awaken them, pulling them gently from the depths of the unconscious into awareness. There are times, however, when recall falters even in the presence of strong cues. The sensation of a word being on the tip of the tongue is a familiar example. The mind knows the memory exists, it can sense its outline, but the precise pathway to it remains just out of reach. This temporary blockage arises from partial activation within the network, where some connections are engaged while others remain dormant. A small shift in attention, or the appearance of a related cue, can resolve the impasse instantly, as the missing link is reactivated. Such moments remind us that memory is not a fixed storage system, but a dynamic process of search and retrieval. The vividness of recall is influenced not only by the strength of memory, but also by imagination. When reconstructing a scene from the past, the brain fills in gaps using familiar patterns and expectations. The visual cortex generates imagery, the auditory cortex recreates sounds, and the prefrontal regions weave coherence. These additions often go unnoticed, blending seamlessly with what was truly remembered. Thus, memory becomes a collaboration between fact and imagination, between what was and what feels true. This creative flexibility allows us to learn from experience, adapting old memories to fit new contexts. But it also explains why eyewitness accounts can diverge, each shaped by the storyteller's mind. Sleep once again supports the process of recall. During the night, the hippocampus replays patterns of neural activity that represent recent experiences, reinforcing the pathways that will later allow retrieval. The cortex, in turn, strengthens its own networks, ensuring that memories are accessible even without the hippocampus's guidance. This quiet rehearsal preserves not only the information itself, but also the associations and cues that enable its recall. By morning, the threads of memory have been woven more securely into the fabric of thought. Recalling the past is not merely an act of looking backward. It is a dialogue between past and present, an ongoing conversation that shapes identity and understanding. Each memory recalled alters not only the memory, but also the self who remembers it. The past is not static. It lives within us, constantly reinterpreted through the lens of the present moment. In remembering, we reaffirm who we are, connecting our current being to the continuum of our own history. As night falls and the mind grows still, the machinery of recall quiets too, its vast networks settling into calm. The hippocampus releases its grasp, and the countless memories stored across the cortex rest in silence, waiting for the next cue, the next spark of recognition. Somewhere within, the essence of who you are, woven from all you have remembered and all you have forgotten, rests as well. Recall is not simply the retrieval of information. It is the awakening of self, the reanimation of time within the eternal present. And in that gentle act of remembering, the human mind finds its continuity, forever bridging what has been with what is yet to come. 14. Sleep and the strengthening of memory. When the world grows quiet and the body surrenders to rest, the brain does not truly sleep. Beneath the surface of stillness, it begins one of its most intricate and essential labors, the strengthening of memory. During these long and silent hours, the mind revisits the experiences of the day, sorting, organizing, and weaving them into the fabric of long-term understanding. Sleep is not merely a pause between waking hours. It is an active state of restoration and refinement, during which the fragile patterns of short-term memory are consolidated into lasting knowledge. Without this nightly process, learning would remain incomplete, and the story of the self would fragment into disconnected moments. Throughout the waking day, the brain gathers vast amounts of information. Sensory impressions, movements, words, emotions, and decisions accumulate in the circuits of the hippocampus and cortex, forming a landscape dense with new connections. But these new patterns are unstable, vulnerable to interference and decay. Sleep provides the time and conditions needed to stabilize them. As consciousness drifts away, the brain begins to replay the day's activity in rhythmic pulses, reinforcing the pathways that represent important information while allowing the rest to fade. This quiet rehearsal, unconscious, continuous, and precise, forms the biological foundation of memory consolidation. Sleep occurs in cycles, alternating between non-rapid eye movement, NREM, and rapid eye movement, REM, stages. Each contributes to memory in its own way. During NREM sleep, particularly the deep, slow wave phase, the brain's electrical activity slows and synchronizes. It is in this state that the hippocampus communicates intensely with the cortex, replaying patterns of neural firing that mimic those formed during wakefulness. These waves of activity, known as sleep spindles and slow oscillations, coordinate the timing of signals, allowing the hippocampus to transfer information into long-term cortical storage. The cortex, in turn, responds with bursts of synchronized activity, integrating the new material into its existing networks. In essence, the sleeping brain is teaching itself, reinforcing what it has learned while erasing what it does not need. During REM sleep, when dreams unfold, the process takes on a more creative dimension. The brain becomes almost as active as during wakefulness, but the patterns of activity are reorganized. The hippocampus, amygdala, and prefrontal cortex engage in dynamic interplay, blending memory with imagination. Emotional memories, in particular, are processed during this stage. The amygdala reactivates feelings linked to the day's experiences, while the prefrontal regions help regulate and integrate them. This nocturnal processing softens emotional intensity, transforming raw experience into understanding. That is why a difficult event often feels less overwhelming after a night of rest. Sleep does not erase emotion. It refines it, allowing memory to retain its meaning without its distress. Studies have shown that learning is deeply dependent on sleep. When people acquire new information, whether it be a list of words, a new language, or a physical skill, they perform better after a period of rest. The hippocampus, which encodes new memories during wakefulness, appears to replay them during sleep, strengthening the neural connections that represent them. This replay can occur thousands of times through the night, ensuring that the pattern becomes ingrained. When sleep is disrupted or shortened, this consolidation process is incomplete, and recall suffers. Even the simplest task can seem elusive when the mind has not been given time to rest and reorganize. The brain is selective in what it consolidates. Not every experience is replayed or stored. The sleeping mind filters, guided by attention, emotion, and significance. Events that carry personal meaning or evoke strong feelings are prioritized, while routine or irrelevant details fade into obscurity. This selective process gives memory its coherence. It ensures that the mind remembers what matters most, constructing a narrative that aligns with identity and purpose. In this sense, sleep is both a biological and a psychological necessity. It preserves not only information, but also the story of the self. The rhythmic activity of slow-wave sleep has another vital function. It restores the brain's capacity to learn. During waking hours, the synapses between neurons grow stronger as new information is acquired. But this strengthening comes at a cost. The overall excitability of neural circuits increases, leaving less room for additional learning. Sleep resets this balance. Through a process known as synaptic homeostasis, weak connections are pruned and excess activity is reduced, restoring the brain's efficiency. By morning, the neural landscape has been renewed, clean, receptive, and ready to absorb new experience. This nightly pruning ensures that memory remains dynamic, continuously refreshed rather than overloaded. Dreaming, though elusive, also contributes to the strengthening of memory. While its images may seem fragmented or surreal, dreams are the product of real neural processes at work. They represent the brain's attempt to integrate new experiences with old ones, blending emotion, memory, and imagination into a symbolic whole. Within dreams, fragments of daily life are woven together with distant recollections, forming patterns that help the mind make sense of experience. It is as though the brain, in its dreaming state, is exploring its own archives, testing connections, and rehearsing possibilities. Many artists and thinkers have drawn inspiration from dreams, their creative insights arising from the very mechanisms that consolidate memory. The influence of sleep on procedural memory, the memory of skills and habits, is equally profound. During sleep, especially during stage 2 NREM and REM phases, the basal ganglia and cerebellum reactivate patterns of motor learning. A musician who practices a piece before bed may find improvement upon waking, the sequences of movement having been reinforced overnight. Similarly, athletes, dancers, and craftsmen all benefit from sleep's silent rehearsal. The body's memory, like the mind's, requires rest to refine its precision. Even when the conscious self is still, the deeper systems of the brain continue their work of perfecting and preserving. Sleep also strengthens associative memory, the ability to connect new information with existing knowledge. When the hippocampus replays the patterns of recent experiences, this integration allows understanding to expand, transforming isolated facts into connected ideas. It is why problems that seem unsolvable by day often find resolution by morning. The mind, unburdened by conscious effort, continues to explore quietly through the night. In these nocturnal hours, the boundaries between logic and intuition blur, allowing insight to emerge from the silent dialogue of neurons. Lack of sleep, by contrast, disrupts this delicate process. When deprived of rest, the hippocampus struggles to encode new memories, and the prefrontal cortex loses its ability to regulate attention and emotion. The result is forgetfulness, confusion, and heightened reactivity. Chronic sleep deprivation not only weakens memory, but also erodes mood, decision-making, and creativity. The balance between hippocampus and amygdala is disturbed, leading to exaggerated emotional responses and difficulty in distinguishing signal from noise. The mind, deprived of its nightly restoration, becomes fragmented, unable to integrate the day's experiences into coherent understanding. The rhythm of sleep is one of nature's most elegant cycles, a quiet dance between restoration and renewal. Every night, the brain withdraws from the noise of the world to tend to its inner landscape, strengthening the pathways that sustain identity and learning. It is a process as old as life itself, shared by creatures across the animal kingdom. Birds, mammals, even certain marine species all show patterns of rest that serve to preserve memory and skill. In sleep, biology and consciousness meet, bound by the same need for continuity. As the night deepens, the waves of brain activity slow and spread, the hippocampus sending gentle ripples across the cortex. Each ripple carries fragments of the day, faces, words, sensations binding them into place. The body lies still, yet within the skull there is movement, a silent rhythm of renewal. Memory is being strengthened, identity restored. And when morning comes, the mind will awaken subtly changed, carrying within it the lessons of the night. Sleep is not the absence of thought, but its continuation in another form, a quiet partnership between rest and remembering. In this way, the sleeping brain becomes the guardian of learning. It is both teacher and healer, transforming chaos into order, noise into meaning. As you drift into sleep, your brain continues its timeless work, shaping memory, refining knowledge, and weaving the delicate thread that connects past to present. In this stillness, the self is renewed, and the vast network of the mind grows a little stronger, ready once again to hold the beauty of experience when the morning light returns. 15. The future of memory. As human understanding of the mind deepens, the study of memory has entered a new and transformative era. Once regarded as a purely mysterious faculty of consciousness, memory is now seen as both a biological process and a potential frontier for technology. The brain's intricate system of encoding, storing, and recalling information has inspired scientists to explore ways of enhancing, repairing, and even replicating it through artificial means. The future of memory may unfold not only within the quiet chambers of the human mind, but also in the merging of biology and technology, a meeting point where neurons and circuits, thought and data, begin to intertwine. To glimpse the future of memory, one must first appreciate its astonishing complexity. Every recollection, every learned skill, every fragment of knowledge is represented by patterns of electrical and chemical activity flowing through billions of interconnected neurons. These networks are dynamic, continuously reshaping themselves through experience. This property, known as plasticity, allows memory to grow, adapt, and heal. But it also reveals its fragility. Neurons die, connections fade, and diseases like Alzheimer's or trauma can unravel the delicate fabric of identity. For centuries, the loss of memory was viewed as irreversible, but the discoveries of the past few decades have begun to challenge that assumption. Advances in neuroscience, genetics, and computing are converging, pointing toward a future in which the boundaries of memory may be extended far beyond their natural limits. One of the most promising areas of exploration lies in the development of neural interfaces, devices that can communicate directly with the brain. These interfaces, made of ultra-thin electrodes or optical fibers, can record and stimulate neural activity with remarkable precision. Researchers have already succeeded in using such technology to restore memory function in laboratory animals and, in early trials, in humans. By mimicking the patterns of electrical signaling that occur during memory formation, these devices can help the brain strengthen or retrieve stored information. They do not replace memory, but rather assist its natural processes, like scaffolding that supports the structure of learning. Over time, as the technology refines, it may become possible to augment memory, enhancing its capacity or compensating for what disease or injury has taken away. At the same time, the study of artificial intelligence has drawn profound inspiration from the brain's memory systems. Modern neural networks, the foundation of machine learning, are designed to emulate, in simplified form, the way human neurons connect and adapt. These artificial systems can store and recall vast amounts of data, recognize patterns, and even learn from experience. Yet, unlike biological memory, which is shaped by emotion, meaning, and context, artificial memory remains purely mechanical, devoid of the warmth and fluidity that characterize human thought. Still, the gap between organic and synthetic intelligence continues to narrow. Each advance in computing, neuroscience, and cognitive modeling brings us closer to understanding how consciousness and memory might one day be mirrored in machines. There are already signs of this convergence in everyday life. Digital devices have become extensions of human memory, holding names, numbers, photographs, and written thoughts that once resided solely within the mind. This externalization of memory storing knowledge in machines has changed how humans think and remember. Rather than memorizing facts, people now rely on networks of information that exist outside the body. The boundary between internal and external memory grows thinner each year, as technology integrates ever more seamlessly with thought. Some call this the rise of extended cognition, the idea that tools and devices have become part of our mental system. In this sense, the evolution of memory continues not only biologically but culturally, expanding the reach of human awareness. Yet, this expansion raises profound philosophical questions. If machines can store and even recall human memories, where does the self truly reside? If technology can enhance or alter memory, how might that reshape identity? Memory, after all, is the thread that binds personal history together. It defines continuity, the sense of being the same person through time. If memory can be edited, copied, or shared, the concept of individuality may itself evolve. A memory once private could become collective, a shared experience accessible through networks that blend human thought with digital architecture. Such ideas, once confined to imagination, are now entering scientific discussion as advances in brain mapping and data storage accelerate. In laboratories around the world, scientists are working to decode the neural signatures of specific memories. By recording the patterns of activity that occur during learning, they have begun to identify the ensembles of neurons, sometimes called engrams, that represent particular experiences. When these patterns are artificially reactivated through stimulation, animals display behaviors that suggest the memory has been recalled, even in the absence of the original stimulus. This work offers a glimpse into the possibility of manipulating memory directly, not only to restore what is lost, but to shape what is retained. While such interventions could help treat disorders like post-traumatic stress or dementia, they also invite ethical reflection. Memory shapes morality, empathy, and personal truth. To alter it is to alter the foundation of being. Beyond the laboratory, the biological study of memory continues to reveal its depth. Researchers are uncovering how genes, proteins, and synaptic mechanisms contribute to the persistence of memory over decades. Certain molecules, such as Krebs response element binding protein, have been identified as key regulators in transforming short-term memories into long-term ones. Others influence the growth of dendritic spines, the small protrusions on neurons that connect with others. Understanding these processes opens the possibility of therapies that could enhance memory naturally through biochemical balance rather than external devices. Perhaps the future of memory will involve not only machines but medicine, a merging of technology and biology that strengthens the mind from within. Still, as much as science advances, memory will always retain its mystery. Machines may one day recall every fact a person has ever known, but they will not remember the scent of a childhood garden with the same tenderness, or the tone of a loved one's voice with quiet warmth. Human memory is not just informational but emotional. It lives in the interplay of thought and feeling, in the subtle resonance of consciousness itself. What makes memory precious is not its accuracy but its humanity, the way it connects perception to purpose, the way it binds love to time. The future of memory, then, will likely not replace the human experience but extend it. Neural interfaces, intelligent systems, and genetic therapies may help preserve or augment the biological foundation of memory, but the essence of remembering, the act of weaving meaning from experience, will remain uniquely human. As these technologies grow, they will invite new forms of reflection, new ways of understanding identity and continuity. Memory may come to exist simultaneously in neurons and networks, in minds and machines, forming a new kind of consciousness that spans the boundary between flesh and code. Perhaps, in the distant future, humanity will look back on this moment as the dawn of a new evolution, a merging of memory's organic and artificial forms. The brain, once the sole keeper of the past, will share its task with systems that amplify and preserve its knowledge. Yet, even in that future, the quiet pulse of human memory will endure the gentle flicker of neurons that hold a name, a face, a feeling. For no matter how advanced technology becomes, memory will remain a deeply personal act, a bridge between what has been lived and what is imagined. As you drift toward rest tonight, consider how your own memories, fragile, vivid, and uniquely yours, are being strengthened in silence. Somewhere within the labyrinth of your mind, ancient biological rhythms replay the day's moments, turning experience into permanence. Beyond them, in laboratories and circuits, humanity is learning to echo that process in new forms. The future of memory is unfolding now, shaped by both biology and invention. Yet the heart of it remains the same, a living continuity of self, the quiet persistence of remembering, the enduring human desire to hold on to time itself. 16. Memory, identity, and the self. Memory is more than the storage of facts or the preservation of experience. Without memory, there would be no sense of past, no understanding of growth, no stable reflection of who one has been or might become. Each recollection, whether vivid or faint, forms a part of that continuity. It shapes perspective, emotion, and belief. Through memory, the present moment finds meaning, connected to the countless moments that came before. The self is not a fixed entity, but a living narrative, continuously rewritten by what is remembered and what is forgotten. To understand identity through the lens of memory is to see how profoundly our sense of self depends on the brain's ability to weave time together. The hippocampus and cortex, working in quiet partnership, build the architecture of this inner world. The hippocampus records the flow of experience, anchoring events in time and space, while the cortex integrates them into understanding, distributing their essence across networks of perception, language, and emotion. Each night, as the brain sleeps, these two systems review and reshape the day's experiences, threading them into the greater tapestry of one's story. Over years, that tapestry grows denser and more intricate, its pattern formed not only by what has been lived, but by how it has been interpreted. Identity arises from this ongoing construction. A person's understanding of themselves, their values, choices, and aspirations is built upon the framework of memory. Past experiences guide present behavior, shaping how one responds to the world. Even subtle memories, tones of voice, glances, familiar scents leave impressions that influence the way we think and feel. The self, then, is not a single point in time, but a continuous flow, a river carrying the reflections of every event it has passed. It is not the same from one moment to the next, yet it is connected, its course shaped by the banks of memory that give it direction. When memory is disrupted, identity begins to blur. In amnesia, where the capacity to form new memories is lost, the sense of continuity collapses. The individual remains alive, conscious, and capable, yet the thread of personal narrative unravels. Without memory, life becomes a succession of disconnected instants, each vivid in itself but unable to form a whole. The past dissolves, and with it the sense of who one is. Such conditions reveal how deeply selfhood depends on recollection, not just on remembering events, but on remembering that those events belong to you. It is not enough to know what happened. One must feel it as part of one's own unfolding story. Even in the healthy mind, memory is selective. We do not remember every moment of our lives, but rather the experiences that hold emotional weight or meaning. This selectivity is not a flaw, it is what gives identity its shape. Memory filters the infinite details of existence, preserving those that align with our sense of self. In doing so, it creates coherence, but also bias. Each person remembers differently, not because the events themselves were different, but because memory is colored by emotion, expectation, and purpose. We remember in ways that reinforce who we believe ourselves to be. Over time, these choices, conscious or not, shape the narrative of identity. The emotional nature of memory ensures that identity is never purely rational. The amygdala, which marks experiences with feeling, plays a crucial role in determining which memories endure. Joy, sorrow, love, and fear all leave deep imprints, embedding emotional texture within the self. These feelings become the lens through which the world is seen. A memory of kindness may foster compassion. A memory of rejection may cultivate caution. In this way, emotion and memory intertwine to create character, the consistent patterns of reaction and perception that define individuality. Through repetition and reflection, emotion shapes belief, and belief shapes identity, forming a self that is at once biological and philosophical, fragile yet enduring. Time deepens this interplay. As people grow older, the relationship between memory and self evolves. Childhood memories, once sharp, soften into impressions. Recent years may blend into patterns rather than events, yet the sense of continuity remains. Memory condenses, distills, and abstracts experience into wisdom, a quieter, broader understanding of life. This transformation reveals something essential about identity. It is not the quantity of memory that defines it, but the quality of meaning drawn from it. The mind, in aging, becomes less concerned with detail and more concerned with narrative. It begins to understand itself not through isolated facts, but through the overarching story that memory tells. Memory also connects identity to others. Shared experiences bind people together, forming collective memory, the memory of families, communities, and cultures. Within these shared recollections lies a sense of belonging, a recognition that the self is part of something larger. Language, tradition, and history become extensions of personal identity, passed from one generation to the next. In remembering together, people reaffirm their place in the continuum of human experience. The songs sung in childhood, the stories told around the table, the rituals that mark time all become threads in the collective fabric that holds humanity together. Through memory, identity extends beyond the individual, uniting many lives into one shared narrative. Yet memory also allows for transformation. Because it is malleable, the self is not bound by what has been, but can change through reflection and reinterpretation. Each time a memory is recalled, it is subtly altered, infused with new context and emotion. This process of reconsolidation makes personal growth possible. A painful memory may, through time and understanding, become a source of strength. A mistake may transform into a lesson. The self, like memory, is never static. It is revised continually, shaped by both the persistence and the plasticity of the mind. Forgetting, too, plays its part, allowing the self to release what no longer serves, to grow unburdened by the weight of all that has been. In the quiet spaces of solitude, memory becomes a mirror. When the mind drifts inward, it encounters echoes of the past, faces, voices, moments reflected in the stillness of awareness. Through this inner dialogue, identity finds clarity. The self recognizes itself, not as a collection of facts, but as a pattern of continuity, a consciousness that endures through change. This awareness brings comfort, for it reveals that even as the details of life shift and fade, the essence of being remains. The same awareness that once gazed upon the world as a child continues to gaze upon it now, changed in knowledge but constant in presence. Memory is the bridge that allows that awareness to recognize its own persistence. As science looks deeper into the mechanics of memory, and technology begins to extend its reach, the question of identity becomes ever more profound. If memories can be enhanced, shared, or even artificially stored, what will happen to the boundaries of selfhood? Would a person who shares their memories with another remain the same individual? Could one's identity be preserved in data, living beyond the biological limits of the brain? These questions are no longer purely philosophical, they hover on the horizon of possibility. And yet, even as the methods of memory evolve, its meaning remains the same. It is the intimate connection between experience and consciousness, between what has been lived and what is known. In the end, memory is not only what we remember, but what we are. It holds the laughter and the tears, the lessons and the hopes, the countless quiet moments that shape the rhythm of being. Through memory, the self is both anchored and free, bound to the past, yet capable of renewal. Each night, as the mind rests, memory continues its quiet work, sustaining identity, refining understanding, and preparing the self to awaken again, whole and continuous. And so, the story of a life is not written in years or accomplishments, but in the invisible record that memory keeps, the tender archive of moments that define what it means to exist. To remember is to be, and to be is to remember. In this endless exchange between experience and awareness, the self endures, luminous and ever-changing, carrying forward the essence of all that it has been, all that it is, and all that it has yet to become. 17. Memory and imagination. The creative mind. Memory and imagination are often spoken of as opposites, the one concerned with what has been, the other with what might be. Yet within the mind, they are twin processes, inseparable and deeply intertwined. Every act of imagination is built upon the foundation of memory, and every memory is, in its own way, an act of imagination. The brain does not store the past as static images, nor does it invent the future from nothing. Instead, it draws upon the same neural architecture to recall, to reconstruct, and to create. The same regions that relive a memory, the hippocampus, the prefrontal cortex, the visual and auditory cortices, also engage when we envision something that has never happened. The mind, in its quiet brilliance, uses memory not only to remember the world, but to imagine it anew. When you recall a place from childhood, your brain does not simply retrieve a photograph stored somewhere in the folds of tissue. It rebuilds the scene from fragments, the pattern of light, the rhythm of sound, the scent of air after rain. These pieces are drawn together by association, guided by the hippocampus, and rendered vividly through the sensory regions of the cortex. The same process occurs when you imagine a place you have never been. The brain borrows from the archive of memory, rearranging familiar elements into new configurations. The imagined landscape feels real because it is built from the very same material as memory perception itself. In this way, imagination is not a departure from reality, but an extension of it, the mind's way of exploring possibilities beyond what has been directly experienced. This overlap between remembering and imagining has been confirmed by countless studies in neuroscience. When individuals are asked to recall a personal memory or to visualize a future event, the same networks activate across the brain. The hippocampus plays a central role, orchestrating the construction of scenes in both past and future. The prefrontal cortex contributes organization and planning, while the posterior regions of the cortex supply imagery and detail. Together, they form what scientists call the default mode network, a system that becomes most active when the mind is at rest, free to wander through time. It is within this network that daydreams are born, where the self drifts between what has been lived and what could be imagined. This intertwining of memory and imagination reveals something profound about the nature of creativity. To create is to recombine, to take what is known and reshape it into something unfamiliar. A painter draws upon the colors and forms they have seen. A writer builds new worlds from remembered emotions. A composer transforms the echo of sound into melody. The imagination does not invent from emptiness. It reweaves memory into patterns that did not exist before. Even the most fantastical ideas, the ones that seem to spring from nowhere, are rooted in fragments of perception and experience stored within the mind. The human capacity for creativity, then, is a reflection of the brain's natural tendency to blend remembrance with possibility. Dreaming provides a vivid example of this process in motion. During sleep, when the conscious mind is at rest, the brain continues to activate memory circuits, drawing upon stored experiences to generate new scenarios. Faces, places, and sensations appear in strange combinations, untethered from logic, yet rich in meaning. The dreaming brain, especially during REM sleep, engages the same regions used for imagination while loosening the constraints of rational thought. In this fluid state, the mind explores connections it might never consider while awake. Many creative insights, scientific discoveries, and artistic inspirations have emerged from dreams, where memory and imagination mingle freely, unrestricted by the limits of waking consciousness. Memory not only supplies imagination with raw material, but also gives it emotional depth. When the mind envisions a future event, it draws upon the emotional tone of similar memories to predict how it might feel. This ability, sometimes called affective forecasting, depends on the amygdala and hippocampus working together. It allows the mind to simulate outcomes, to prepare for joys or challenges that have not yet arrived. Imagination, in this sense, is an evolutionary gift. It enables foresight, empathy, and innovation. By combining fragments of remembered experience with projection, humans can plan, create art, build societies, and even ponder the nature of their own existence. The act of imagination, like memory, is deeply influenced by emotion and attention. A memory recalled in tranquility may inspire a calm and contemplative vision, while one tinged with sorrow or nostalgia may shape a darker or more tender creation. The artist who paints from memory is guided not by accuracy but by feeling the light in their painting, reflects not only what was seen but what was felt. In this way, imagination is memory transformed by emotion. It gives form to the ineffable, translating the internal resonance of experience into symbols and stories that others can share. When the imagination turns inward, it becomes the source of reflection and understanding. Through memory, the mind revisits the past. Through imagination, it explores meaning. It asks, what could have been? What might yet be? What does this reveal about the self? This dialogue between what is known and what is possible forms the basis of human insight. It allows people to reinterpret their lives, to reshape their stories in ways that bring coherence and purpose. Imagination becomes a tool for healing, enabling the reimagining of painful memories through compassion and growth. What once was a source of sorrow can, through reflection, become a story of resilience. The creative mind relies on this delicate interplay between remembering and imagining. Scientists often describe memory as constructive, but artists have always known it intuitively. The storyteller who recalls a moment from long ago does not repeat it exactly. They breathe new life into it, allowing imagination to fill the spaces that memory has left blank. What emerges is not falsehood but transformation, a truer truth, perhaps one that captures the spirit rather than the fact. In this way, imagination preserves the living essence of memory, ensuring that it continues to evolve rather than fossilize. The same mechanisms that allow for creativity also enable empathy. To understand another's experience, one must imagine it, drawing upon one's own memories to simulate their perspective. The neural circuits involved in this process overlap with those of memory and imagination. When you picture someone's joy or pain, your brain activates the same emotional and sensory regions that would respond if you experienced it yourself. Memory provides the foundation for this empathy, while imagination bridges the gap between self and other. Thus, the creative mind is also the compassionate mind, capable of transforming remembrance into understanding. Even as science maps these processes in finer detail, the mystery of imagination remains vast. It is not merely a byproduct of memory, but its evolution, the mind's way of transcending time. Through imagination, memory becomes dynamic, allowing the past to converse with the future in the present moment. Every human creation, from art to invention, from poetry to philosophy, arises from this conversation. The mind remembers the world as it has been and imagines it as it could be, building bridges between reality and possibility. As night falls and the mind drifts toward rest, memory and imagination continue their quiet exchange. The hippocampus replays the day's impressions, the cortex reshapes them, and the dreaming brain begins its silent art, painting with the colors of experience upon the canvas of sleep. Tomorrow, fragments of those nocturnal visions may linger an idea, a melody, a feeling reminders that imagination never sleeps. It is always at work, transforming what has been into what may yet come. Memory gives imagination its substance. Imagination gives memory its life. Together, they make the mind a place of infinite creation, a space where the past and the possible coexist, where thought becomes art, and where the self continues to unfold, endlessly reimagined. 18. Collective memory, the shared mind of humanity. Memory does not belong to individuals alone. It moves between people, across generations, and through the fabric of culture, becoming something larger than any single mind. This shared reservoir of remembrance is known as collective memory, the living continuity of human experience that binds societies together. It is the memory of humanity itself, preserved not only in words and stories, but in rituals, symbols, and the quiet traditions that shape daily life. Collective memory is the invisible thread that connects the present to the past, allowing each generation to inherit more than its own experiences. Through it, humanity remembers who it has been, what it has learned, and what it hopes never to forget. Unlike personal memory, which resides within the biological architecture of the brain, collective memory lives in communication and culture. It is formed through language, art, custom, and shared history. When people gather to tell stories, celebrate, or mourn, they participate in the preservation of this greater memory. Each voice adds detail to the whole, reaffirming identity through shared remembrance. In a village, a city, or an entire civilization, collective memory shapes values, defines belonging, and offers continuity through change. It tells people where they have come from. The roots of collective memory stretch back to the earliest human communities. Before writing, knowledge was carried in the spoken word songs, myths, and legends that encoded history and wisdom in forms easy to remember. Storytellers were the living archives of their people, ensuring that the lessons of the past were passed forward. Through repetition, these stories became part of collective identity. They explained the origins of the world, the order of society, and the relationship between humanity and nature. In this oral tradition, memory was not an individual possession but a shared duty, an act of continuity between ancestors and descendants. The invention of writing transformed this process, allowing memory to take physical form. Stone, clay, and parchment became vessels of remembrance, expanding the reach of collective thought. What was once confined to the human voice could now endure across distance and time. Societies began to record laws, chronicles, and philosophies, creating archives that outlived their creators. In these records, the collective mind of humanity found permanence. Writing freed memory from the limits of biology, allowing civilizations to grow upon the accumulated knowledge of those before them. The scrolls of Egypt, the tablets of Mesopotamia, the libraries of Greece and Rome, all were extensions of collective memory, each contributing to the slow unfolding of human understanding. Yet even as it gained permanence, collective memory remained selective. Societies choose what to remember and what to forget, guided by the needs and values of their time. The stories preserved are those that reinforce identity or serve moral purpose. Others fade into obscurity. This selectivity shapes culture, just as individual memory shapes identity. It determines which heroes are honored, which events are commemorated, and which lessons are carried forward. Through commemoration, societies reaffirm their values, celebrating courage, mourning tragedy, seeking meaning in both triumph and loss. Monuments, ceremonies, and national holidays are outward expressions of this process, physical manifestations of the invisible memory shared by a people. The collective memory of humanity is not static. It evolves with each retelling. As generations reinterpret the past, they reshape it to fit new perspectives and challenges. Historical events gain new meaning as understanding deepens. What was once forgotten may be rediscovered. What was once glorified may be questioned. In this ongoing reinterpretation, collective memory mirrors the plasticity of the human brain. It grows, adapts, and sometimes heals. The ability of societies to revisit their memories, to learn from them, and to reconcile with them determines their moral and cultural maturity. A healthy collective memory, like a healthy mind, does not cling rigidly to the past, but learns to integrate it with compassion and insight. Art and culture serve as the great vessels of collective memory. A painting can hold the grief of a generation. A song can carry the hope of a people. These creations preserve memory not as cold record, but as living feeling. They bridge the gap between time and empathy, allowing those who come after to feel what their ancestors felt. A symphony, a poem, a story, each becomes a form of remembrance, storing the emotional truth of an era in a language that the heart can still understand centuries later. Religion, too, plays a profound role in sustaining collective memory. Sacred texts, rituals, and traditions carry the accumulated wisdom of faith communities across millennia. Through repeated practice and retelling, these rituals renew the link between past and present, uniting the living with those who came before. Festivals mark the rhythm of remembrance, and prayers preserve continuity through repetition. In this way, belief itself becomes a form of memory, a spiritual echo that reminds humanity of its enduring questions and shared search for meaning. In the modern world, technology has expanded collective memory to unprecedented scale. The written word has given way to the digital archive, where billions of lives leave traces that can be stored indefinitely. Every image, message, and record contributes to a vast network of remembrance, a global memory system that transcends geography and time. Yet this abundance brings new challenges. When everything is preserved, how does society decide what matters? The human mind evolved to forget selectively, but digital memory does not. It holds everything trivial and profound alike, creating an endless archive without the natural rhythm of loss. In this new landscape, humanity must learn again the art of discernment, deciding not only what to remember, but also how to interpret it. Despite its technological reach, the essence of collective memory remains human. It is carried in empathy, in the stories people tell each other, in the shared emotions that flow through communities. It is felt in the silence of memorials and the laughter of festivals, in the languages that shape thought and the art that expresses the soul. Collective memory allows humanity to transcend individuality. Every generation inherits not only the knowledge, but also the emotions of those before, the griefs and joys, the mistakes and the wisdom. Through this inheritance, the species learns to remember not merely with the mind, but with the heart. The fragility of collective memory reminds us of its importance. When societies forget, when history is erased or rewritten, the lessons of the past fade, and the mistakes of humanity return. To remember together is to safeguard against that repetition. Memory is not merely preservation, but responsibility. It asks each generation to bear witness to what has been, to honor truth, and to carry forward understanding. The collective mind of humanity depends upon this continuity, upon the willingness of individuals to remember not only their own lives, but the lives of others. As evening falls and cities settle into quiet, the world's countless memories remain alive in the whisper of stories, in books resting on shelves, in data floating through invisible networks, and in the unspoken awareness shared between people. Somewhere, a mother tells her child a story once told to her, and in that simple act, The chain of memory continues, unbroken. Humanity remembers itself in such moments through tenderness, through knowledge, through the shared rhythm of existence. Collective memory is the soul of civilization, the dream of continuity that connects all who have lived, all who live now, and all who are yet to come. It is the great mirror of humanity, reflecting both its light and shadow, its wisdom and its longing. Through it, the past remains alive, and the future is shaped by remembrance. And in this vast, unseen web of shared memory, every thought, every creation, every act of kindness becomes part of something greater, the eternal memory of humankind, ever expanding, ever evolving, held together by the invisible grace of remembering. 19. The limits and mysteries of memory. Memory, for all its vastness and wonder, remains one of the greatest mysteries of the human mind. It defines who we are, anchors us in time, and gives meaning to experience. Yet it also eludes complete understanding. The more deeply science explores it, the more intricate it becomes, an ocean whose depths seem to recede as we approach them. For every answer uncovered, new questions emerge. Where does memory truly reside? How can something as delicate as a thought endure within the fragile substance of the brain? Why do some moments remain vivid for a lifetime, while others vanish almost instantly? And what is the relationship between memory and consciousness? Between the storage of experience and the awareness of being? These questions form the frontier of the human search for self-knowledge, where biology meets mystery and the boundaries of understanding begin to blur. At its most basic level, memory is a physical process, encoded in the structure and chemistry of the brain. Neurons communicate through electrical impulses and chemical messengers, forming networks that strengthen with use and weaken with neglect. This plasticity allows experience to leave a trace upon the neural fabric. But even as we trace the pathways of these connections, something essential escapes our grasp. How does the firing of neurons translate into the subjective feeling of recollection? The scent of rain, the sound of a voice, the warmth of a remembered touch. No map of the brain, however detailed. The mystery of memory is also the mystery of consciousness itself. There are limits to what we can remember, and those limits shape the very nature of human experience. The brain cannot hold every detail of life. It must select, compress, and interpret. What is preserved is not the world as it was, but the world as it was experienced. Memory filters reality, distilling it into meaning. This selectivity is not failure but necessity. It allows understanding to emerge from the chaos of sensation. Yet it also introduces distortion. No memory is completely faithful. Each is reconstructed anew with every recall. Even the most vivid recollection is partly imagination, a blending of fact and feeling. The mind, in remembering, also reshapes. Thus, every human life is built upon stories both true and altered, memories that are accurate enough to guide but fluid enough to evolve. There are also memories that lie beyond reach, those that were never consciously formed or that dwell beneath awareness. These implicit memories shape behavior without entering thought. They govern instinct, habit, and emotional reaction. The body remembers what the mind forgets. The subtle tension that arises in a familiar situation, the comfort found in a scent from childhood, the sudden unease triggered by an echo of the past. Such memories reveal that remembrance does not belong solely to consciousness, but to the entire organism. The muscles, the senses, even the autonomic nervous system carry their own quiet forms of memory, contributing to the seamless flow of being. At the other extreme lies hyperthymesia, the rare condition in which individuals can recall nearly every detail of their lives with astonishing clarity. The ability to remember everything means never escaping the weight of the past. Each day accumulates without release, and every emotion remains vivid. For most minds, forgetting is a mercy. It allows healing and renewal. The limits of memory are thus protective. ensuring that the self can move forward. The mind must balance remembrance and oblivion, knowing that too much of either would dissolve its coherence. Memory's limits are also temporal. It gives us a sense of the past, but only within a narrow span. Beyond living recollection, we rely on records, stories, and artifacts to extend the reach of memory. The ancient world survives through fragments, texts, ruins, and echoes carried forward by collective remembrance. But even collective memory fades with time, as generations reinterpret and transform what came before. Human history is built upon this tension between remembering and forgetting, between preservation and loss. What endures shapes identity. What disappears leaves room for new creation. Thus, forgetting is not the enemy of memory, but its silent partner, ensuring that the flow of time remains open and alive. Some mysteries of memory emerge not from its loss, but from its persistence in unexpected ways. There are cases of amnesia in which individuals forget their personal past, but retain their skills, and others in which memory seems to return suddenly after years of absence. There are moments of déjà vu when the present feels hauntingly familiar, as if echoing an unseen memory. There are instances in which trauma imprints memories so deeply that they intrude unbidden, while other traumas seem to erase memory entirely. The variability of these experiences suggests that memory is not stored in one place or in one form, but is distributed across the mind, like threads of a vast tapestry, some woven tightly, others loose and fragile. Science continues to uncover how deeply interconnected these threads are. Memories once thought lost may remain dormant, hidden in the architecture of the brain, awaiting the right cue to reactivate them. Research into memory reactivation and reconsolidation shows that the past is not fixed. It is constantly rewritten. When a memory is recalled, it becomes temporarily malleable before being stored again, allowing it to be updated or reshaped. This process is both an opportunity and a danger. It permits healing, reframing painful memories, but also allows distortion, making truth fluid. The mind, in its complexity, holds within it both the capacity for accuracy and the inevitability of change. Perhaps the greatest mystery lies in the persistence of certain memories that defy time and explanation. Some people report memories from very early infancy, from dreams, or from moments of deep emotional resonance that seem to transcend ordinary experience. Others describe sudden floods of recollection triggered by art, music, or scent, as though time momentarily collapses and the past becomes present again. These phenomena remind us that memory is not simply linear but layered, existing beyond the boundaries of chronology. It is an ocean of experience where moments coexist, where what has been may still be felt, and where the self continually re-encounters its own depths. Philosophers have long pondered the relationship between memory and immortality. If memory is what preserves the self, then to lose it is to lose being. Yet, in another sense, memory allows the self to transcend time, for as long as one is remembered by others, by words, by the quiet record of influence, one continues to exist in the collective mind of humanity. Every thought shared, every kindness offered, every creation made, becomes part of a larger continuity. Memory thus bridges mortality and eternity, ensuring that what is meaningful endures beyond the limits of individual life. Even with all our knowledge, memory remains partly unknowable. It dwells at the intersection of matter and mystery, where neurons hum with electrical fire and consciousness awakens into awareness. It is both the most familiar and the most enigmatic aspect of being. Every moment we experience becomes part of its unfolding, yet we can never fully see it from outside ourselves. We live within memory as fish live within water, surrounded, sustained, and unaware of the medium that holds us. And so, as the day fades and thought softens, the mind continues its quiet work. Memories drift through awareness like faint stars, some bright and near, others distant and unseen. They shimmer, overlap, and dissolve, creating the gentle continuity of consciousness. What is forgotten returns in another form, and what is remembered transforms with each passing moment. The limits of memory are not barriers, but invitations to wonder, to reflect, to accept the mystery that the mind itself cannot fully comprehend. For within those limits lies the beauty of imperfection, the grace of change, and the quiet reminder that to remember is to be human, to live within the delicate balance of knowing and not knowing, of holding and letting go. 20. The harmony of remembering, a gentle conclusion. Memory is the silent companion of every human life. It moves with us through the years, invisible yet ever present, shaping the contours of thought, emotion, and understanding. From the first moments of awareness to the final flickers of reflection, memory gives life its continuity. It is the soft pulse that connects each instant to the next, transforming experience into meaning. As we have journeyed through its landscapes, from the mechanics of neurons to the poetry of identity, we arrive here at the quiet recognition that remembering is not a single act, but a harmony. It is the blending of many notes, biological, emotional, imaginative, and spiritual, into a single, enduring song. In the stillness of reflection, one may begin to sense this harmony. Every memory, whether sharp or fading, contributes to the melody of self. Some are bright, resonant chords, moments of joy, discovery, or love that linger long after they have passed. Others are soft undertones, barely audible yet essential to the fullness of the sound. Together they create a living composition, unique to each person yet echoing the universal rhythm of human experience. To remember is to participate in this quiet music, to be aware of the countless impressions that have shaped one's being. Memory, though often described as a storehouse, is more like a living river. It flows through consciousness, sometimes calm, sometimes swift, carrying fragments of time within its current. What it carries changes with each season of life. Childhood memories, once vivid, become distant ripples. New experiences join the flow, and over time, the river deepens, becoming slower but more reflective. This continuity allows the self to recognize itself through change, even as the body grows, as surroundings alter, and as years pass. Memory preserves a sense of familiarity, a quiet assurance that one's essence endures. The harmony of remembering lies not only in retention but also in forgetting. Just as music depends on silence between notes, memory depends on the spaces of forgetting to give shape and clarity. Without forgetting, life would be an overwhelming chorus of sound, with no room for reflection or peace. Forgetting is the gentle pause that allows the mind to rest, to let go of what is no longer needed, and to prepare for what is to come. It is the still breath between thoughts, the soft closing of the page that allows the next chapter to begin. In this balance between remembering and releasing, the mind finds serenity. Throughout the journey of life, memory serves as both compass and mirror. It guides action by recalling the paths already taken and reflects the meaning of those choices back upon the heart. When we look inward, we see not isolated moments but patterns, the lessons learned, the love given, the times of wonder and of grief. These patterns form the wisdom that memory bestows, a wisdom that grows not from the quantity of what is remembered, but from the depth of understanding it brings. In remembering, the mind learns to see life not as a series of fragments, but as a continuous unfolding, where every experience has contributed something essential to the whole. The harmony of memory extends beyond the individual. Each life, through its memories, contributes to the collective song of humanity. Stories, art, knowledge, and tradition all arise from the human desire to preserve experience, to pass it forward. When one person shares a memory, it becomes part of another's mind. Through conversation, teaching, and creation, the boundaries between personal and collective memory blur. Humanity remembers itself through these exchanges. maintaining an unbroken continuity across generations. In this shared remembrance, each voice, no matter how small, adds a note to the symphony of existence. There is also a spiritual quietness in the act of remembering the awareness that to recall a moment is to hold time in the palm of consciousness. The past, though gone in form, becomes alive again through attention. When you remember a person who is no longer present, a place that has changed, or a time that will never return, you are not merely looking backward, you are affirming the timelessness of experience. Memory becomes a bridge across time, allowing the heart to touch what the hands cannot. It is through this bridge that love endures, that wisdom persists, that beauty continues to echo beyond its moment. As age advances, memory often takes on a softer texture. The sharp details of youth blur, leaving behind impressions and emotions rather than precise images. Yet in this softening, something deeper emerges, a sense of peace, of continuity without need for precision. The mind learns to dwell not in the exactness of recall, but in the feeling of life as a whole. The past becomes not a collection of events, but a landscape of meaning, one that the self can walk through gently, revisiting with affection rather than attachment. In this way, memory becomes an art of acceptance. To remember well is not to cling, but to honor. Even as science continues to unravel the workings of memory, there remains within it something ineffable, something that cannot be reduced to circuits or chemistry. Memory is not merely stored within the brain, it lives within awareness itself. It is the presence that looks back upon its own history and recognizes, I have been. It is the quiet continuity of consciousness, the same spark that has witnessed each sunrise, each gesture, each word. This self-recognition, the knowing that remembers knowing, is perhaps the most profound harmony of all. It reveals that beneath the changing waves of memory lies an unchanging sea of awareness. The harmony of remembering also teaches compassion. To recall one's own past struggles is to understand the struggles of others. To remember joy is to recognize it when it appears again, even in another's life. Memory connects not only moments but hearts, weaving empathy from shared experience. When humanity remembers together the triumphs, the mistakes, the dreams, it grows wiser. Collective remembrance becomes a teacher, reminding us that we are all threads in the same tapestry, bound by time, learning and relearning the art of kindness through the stories we keep. In the quiet end of reflection, one may come to see that memory is not only the record of life, but the rhythm of existence itself. Every breath, every sensation, every thought arises and fades, leaving behind the faint imprint of experience. These imprints gather, layer upon layer, forming the awareness of being alive. To remember is to participate in the unfolding of consciousness, to bear witness to the passage of time and to the beauty of change. Memory is both the echo in the song, the reflection in the light. And so, as the journey through the mind's vast terrain draws to a close, the harmony of remembering continues. It hums softly in the background of thought, in the stillness before sleep, in the whisper of dreams. The neurons of the brain rest yet remain alive with quiet fire, carrying the weight of all that has been. The self rests, too, comforted by the continuity that memory provides. There is peace in knowing that even as moments pass, their essence remains, that nothing truly lived is ever entirely lost. Memory, in its fullness, is not a possession, but a presence. It is life remembering itself, the gentle pulse of awareness moving through time. It holds the laughter, the sorrow, the wonder, and the silence. It is both fleeting and eternal, fragile and immeasurable, and in its harmony, it reminds us of a simple truth, that every moment, once lived and remembered, becomes part of something greater, an unending melody that flows through all of existence, quiet, timeless, and beautifully complete.